All right, if you could grab your seats and we will begin. Thank you. So welcome to our December meeting. You may not have noticed that it's still December on your calendar, but this is our December meeting, so it must be December. The cherry blossoms and all that aside, we're going to proceed. Something about President Bush interrupting former President Bush interrupting our December meeting, and then some other event in January seemed to delay things. I don't remember what that was all about, but we are here, and we're delighted to be here. Many of us around the table had the opportunity to get together for dinner last night. It was a great event, a great opportunity to celebrate our now departed, but looking really relaxed. And the TAC members will appreciate that comment, inside joke. But our former designated federal officer, Walter Johnston, and this is the first meeting for Michael Ha, and he doesn't even have his DFO designation on his card, so we have to get that updated. But it is a special time, and we will be reviewing the results of last meeting. Actually, I have a lot of things going on today. The results of the last year's worth of meetings, those all-important actionable recommendations that have been produced, and with the extra quarter to buff them up, they really come through very nicely. The white papers that have been produced and the report from the Mobile Device Theft Prevention Group also have, again, with that additional 3 months, I think the groups have polished up their recommendations for further work in each of the groups as well, so we'll look forward to seeing those. We do have the agenda on the screen. As usual, probably no one can read the agenda on the screen, but we'll proceed first with some opening comments, and we're honored to have Matthew Berry here. The chairman is not able to be here, so he sent someone who would really give us the message on what's going on the 8th floor. And so we're delighted to have Matthew here. Actually, I had the opportunity to hear Matthew speak, and he does tell exactly what's going on, and that's greatly appreciated. So we'll move forward into that as soon as we've done our traditional once around the table. So already introduced you, but go ahead and introduce yourself again, Matthew, and then on around the table.
I'm Matthew Berry, the FCC's Chief of Staff. Walter Johnston, former DFO and native Texan.
Clearly from your accent, that's true.
Michael Ha, the new DFO.
Lynn Claudy, National Association of Broadcasters.
Paul Meisner at Amazon.
John Barnhill with Alianza.
Mark Bayless of Visual Link.
Dick Green, Liberty Global.
Brian Markwalter, Consumer Technology Association.
Steve Lanning, Viasat.
Nomi Bergman with Advance.
Marty Cooper, Dyna LLC.
Greg Lappin, ARRL.
John Chapin, Roberson Associates, representing the National Spectrum Consortium.
Stephen Hayes, Ericsson Incorporated.
Russell Jurek, Cisco.
Lynn Merrill, NTCA.
Melanie Tiano, CTIA.
Marvin Serbio of Carnegie Mellon, serving as special government employee.
David Tenenhouse, VMware.
Jack Nishelski from Qualcomm.
Kevin Letty, Charter Communications.
Hello, Hamid Memor from Samsung.
Mark Hess with Comcast.
Ed Julio, NTIA.
Karrik Kuoppamäki, T-Mobile USA.
Dale Hatfield, University of Colorado.
Eric Berger, FCC CTO.
Julie Knapp, Chief of the FCC's Office of Engineering and Technology.
And are there any on the phone? Michael, do we have the bridge open?
We should have a bridge up.
Anyone on the phone?
Just moving, maybe they're just logging in.
Yeah, can you hear me?
Yes.
Hi, this is Brian Daly, AT&T.
And I hope you're feeling well, Brian.
Yes, thank you.
Any others? Brian is the only one that I know that was going to be on. Brian's had a little bit of a health issue that keeps him away, but he will be engaged, even with my encouragement that he take good care of himself. But well, delighted to have you on. With that, let me turn things over to Matthew for the view from the top.
Okay, well, thank you, Dennis. And I'm definitely going to keep my remarks brief this morning so that we can get to the important, really important things, which is hearing the recommendations and all the work that the working groups have been doing. But on behalf of the Office of the Chairman, it's my honor to welcome this distinguished assemblage of some of the nation's leading engineers and technologists to the Commission. Chairman Pai is out of town doing Commission business in California this week and couldn't be with you personally this morning. But as a show of respect and appreciation for your contributions to the Commission, he sent the next best thing in his stead.
Uh-oh. I know what's coming.
But in all seriousness, it's an honor and privilege for me to be filling in for the chairman this morning. And I think the greatest testament to how much we value your work is to look at the agenda that we've pursued over the past 2+ years. Just last week, for example, we announced that our April meeting will feature the latest rulemaking as part of our Spectrum Frontiers proceeding, which sprang from the foundational work by this TAC. Right now, we're in the Spectrum Frontiers proceeding. We're in the middle of a 24 gigahertz auction. We completed a 28 gigahertz auction earlier this year that started in November. Later this year, we'll be auctioning off 37, 39, 47 gigahertz spectrum, all stemming out of the Spectrum Frontiers proceeding. The same could be said of other major proceedings, like our work on 3.5 gigahertz and our work on tech transitions. So this TAC isn't crafting think pieces that get filed away in somebody's desk drawer. You're developing action items that help to drive the Commission's work to promote technological innovation. And for that, all of us at the Commission and all of us in the Chairman's office are deeply grateful. So the good news is that you have proven yourself indispensable to the Commission. And the bad news is that you've made yourself indispensable to the Commission and must continue your work. So as long as promoting technological innovation is at the heart of the Commission's mission, and I certainly hope that won't change anytime soon, there will be a need for the expertise offered by the TAC. So instead of letting you take a victory lap last year for past successes, the TAC chartered 5 new working groups on topics ranging from 5G in the Internet of Things to spectrum for unmanned aerial systems. Today's meeting will feature presentations with actionable recommendations coming out of these working groups. I can assure you that the Chairman's office will be reviewing all of these recommendations closely and taking action where appropriate. I also understand that at the conclusion of today's meeting, you will be celebrating the TAC's 20th anniversary. Just think, one more year until the TAC is old enough to drink. Nonetheless, I'm sure today's celebration will be a lively affair. I hope you have a great time because you deserve it. And I'd like to thank those who made this celebration possible. First, thank you to the members of the TAC. The fact that you are industry-leading experts means that your time is incredibly valuable. The fact that you volunteer that valuable time to the TAC is a true public service, and there should be no doubt that those of us at the Commission truly appreciate that service. Thank you to the TAC's leaders, Dennis Roberson, and also the many working group leaders. Your vision and management skills have been integral in harnessing all the expertise in this room and translating it into results. Finally, thank you to Julie Knapp, Walter Johnston, the new Walter, Michael Ha, everybody in OET, and everybody at the Commission who have nurtured this relationship and integrated the TAC's efforts into the Commission's work. As Chairman Pai often says, the Commission staff is our greatest asset, and Julie, Walt, Michael, and the OET team are as good as it gets. And finally, since today would have been Leonard Nimoy's 88th birthday, I thought that it would be appropriate to close with the following wish for the TAC as you celebrate your 20th anniversary. Live long and prosper. Thank you very much.
No, thank you so much. Appreciate your comments. Appreciate you giving the representative perspective. I mean, this is an extraordinarily valuable piece. I am amazed that the chairman allowed that to be out of his grasp long enough even to represent himself here.
I'm sure it's only a copy. But there's 40 or 50 of them.
Does it qualify as a carry-on?
Since we're talking about artifacts, I will point out to the group that we do have other artifacts here. As part of our 20th celebration, there was a request for the TAC members to bring various memorabilia from their days, and maybe they're not all yet displayed, but we do have a couple of tables for those on the TAC and those in the audience to view. I will present the rationale for the cell phone table on the left. One of my habits at the very start of the TAC was to, when I was Chief Technology Officer of Motorola, was to bring approximately a dozen phones to each of the meetings. So we always started out the meeting with Bob Luckey asking, okay, Dennis, show us the phones. So that had a historic background, and so these were literally some of the phones and related devices that were in my possession and presented here at the TAC at the very beginning of the TAC 20 years ago. And yes, I was there 20 years ago, amazingly. Let me pass things over to Julie for any pearls of wisdom that he would wish to share with the group.
Well, you really had me nervous, Dennis, when you said I want to talk about some artifacts. And here's Julie Knapp.
The background is in front of me is Julie Knapp on my screen. So.
No, just certainly can't top the remarks from the chairman, and without the support from the chairman and the commissioners and the other staff around the agency, I don't know that this could happen. So just want to reiterate our thanks up front for all the time and the energy and the thought that you put into helping the commission understand technology, the things that we should be looking at, the things you think we should be working on. So we're at a point where we need to renew the charter of the TAC, and we are doing that. But as part of that process, we also need to renew the membership. So we're anticipating, I don't know that it'll be later today or tomorrow, there'll be an announcement going out, and hopefully folks will reapply because we have to go through this process for legal reasons all over again. So just a heads up, I think as we go through some of the working group recommendations, and some of them are to continue, all of those are being taken seriously, but we also have to just go through the mechanics of renewing the membership. And hopefully, although I don't know why you would, continue your participation for all of the time and energy that you put into this, other than the service to the country and how much we appreciate it. Thank you.
Thank you. There have been a lot of questions about this topic, so if you have additional details that you'd like to hear about our new designated federal officer, Michael will be happy to share those with you. All right, as Matthew said, let's get on with the meat of the meeting, although we've already had some very helpful insights provided to kick the meeting off. But let's jump in, and our first topic is our Antenna Technology Working Group, led by Marty Cooper and Greg Lappin.
I thought I'd start by making a very general comment, and then Greg is going to go into the details. We discovered two things in this group. One is that it's very hard to overcome the basic physics of antennas. They got to be longer and in a big area. So there's not much that has happened there. But at the other extreme, the combination of physical antennas and lots of signal processing is creating an enormous opportunity for society and for the FCC. And the thing that we discovered that was very exciting, because as Julie knows, I've been talking about this for, seems like 100 years, not just 20.
But it's happening.
Yeah, it's starting to happen, Julie. And what is happening is that of using this combination of physical antennas and processing, we are able to carve out areas and cover the areas very precisely to contain the RF, and that permits us to do the kinds of sharing that we've never thought about before. So it's an enormous opportunity. And when Greg finishes, I want to talk a little bit about what I would hope the FCC and this group would do in the future. So, Greg.
If we could have the slides, please. The clicker.
Clicker's coming down.
Don't throw it.
Another bit of the history.
Yes.
For those new to the group, the chairman, the then current chairman, once took the clicker and threw it across the table. After having his hands wrapped, that has never happened again.
You'll notice a previous date on this lead slide, but that's not today. But we were able to come up with quite a bit of information over the year that we spent working on this. We had a very active working group. People came. We had a weekly call, and a large majority of these people were on each call, and we really appreciate that. We got a lot of input, a lot of interest in this topic, and hopefully we learned quite a bit. We were tasked with reporting on the state of development of antenna technologies, not just new antennas and not just for 5G or millimeter wave, but for everything. What has happened with antennas at lower frequencies? How can antennas help the entire spectrum, not just the new bands that are coming on? Many of the things that are happening are multi-element arrays that do better focusing, because when you can do better focusing, you decrease your interference. The metamaterials were very interesting. We studied them for several weeks and pretty much determined that they're not really ready for prime time at the moment, but they will be. And when they are, I think it'll be very exciting. The different forms of MIMO, massive MIMO, distributed MIMOs, SDMA, and other technologies, as Marty talked about, are promising to give us much increased spectrum efficiency. Today's higher frequencies will allow for smaller sizes. That's the physics that Marty talked about. And the smaller sizes allow us to do a lot of more complex things with antennas. The necessity for a large number of frequency bands, however, presents challenges. How do you build an antenna that can resonate at the many different frequency bands that have been assigned? And unfortunately, those bands don't get assigned with respect to the physics. They get assigned with respect to availability. So you don't always get one antenna that will resonate on all these different frequencies. There has been work on that, and very impressive work that makes it almost impossible to tell that there are a large number of antennas that are placed in a very small space. Finally, we were introduced, we didn't start to work on this, but we were introduced to the problem of unsightly antennas. Not necessarily what we thought was our problem, but unless people will accept antennas being placed all over their neighborhoods, they probably won't be. So we delved into that quite a bit. We investigated array antennas for beamforming, electronic steering, and central processing. And additionally, we looked at reflect arrays, which would give a little more gain in the right direction. The metamaterials promised to give us much smaller antennas than physics would predict. So if you're living in the days of quarter and half wavelength antennas for the very much longer wavelengths, metamaterials are shrinking those down sometimes by 100 times. And if you think about the resistance to antennas, and if you're able to make them that much smaller, then you will get less of that resistance. But as we found out, it's still in early days. It's not ready to be put out on the street. But we're looking forward to some great things in maybe in the next 10 years. Millimeter wave antennas for small cells and for satellites. Some great progress has been made there. And then we also looked into how can we design better antennas? We looked at modeling tools. Can it be done in the computer, modeling before we go out and, like in the old days, did trial and error? And it's very hard to test antennas, so we looked at that. How do you model and then test that you're getting what you would like to get? Some other things that proved very interesting, people are designing antennas that incorporate interference rejection. We have, in the TAC, in past years, have studied interference in many ways, and it's always a problem. But if you can design antennas that will reject interference but let your signal through, that's a major advancement. Filtering antennas is something that would allow you to take some of the electronics out of the devices. All those cell phones over there have lots of filters in them. If you could do that, your cell phone could get even smaller, and you move the filters up into the antenna. Then we started looking at quasi-optic antennas. In other words, frequencies that are so high that they're usually not allowed to be used. And we'll talk a little about that and some recommendations we have to try and advance that. We were also introduced to other materials besides metal for making antennas, gas plasma, and one group that is actually spraying antennas onto fabric called MXZine. We have presented this before, so I won't spend much time on this, but we've had usually an expert speaker each week on our weekly phone call. And these were some of them. In metamaterials, we had 3 different people talk about it. 2 of them that are trying to commercialize metamaterials already, and then 1 professor who told us about all the wonderful things that could be done someday with them. We talked about smart antennas, and we had several speakers tell us about how a smart antenna will create what some people call a personal cell. So instead of the energy emanating all over, it focuses just at the person who's using it, the personal cell. And that greatly decreases interference and allows frequency reuse. So that means more users in a cell site. We also looked at smart antennas that offer capabilities in millimeter waves and below 6 gigahertz frequencies. They're different than these personal cell antennas just because the multipath is made use of, and the multipath is very different at those frequencies. We had several people tell us about electronically steerable antennas, and if you steer, you think that you just want to steer the beam at the person who's using it, or the other end that's using it. But we also found out that we had one person speak to us about setting up a Wi-Fi with steerable, very steerable beams, greatly decreasing the number of hotspots that were needed in a large area. The testing is always going to be an issue. And we had an expert on testing from Ericsson tell us about the very many number of tests he needs to do on a new antenna and how it can take months to do those tests. We also talked with someone from the OET lab who clued us in and educated us about what rules currently exist related to antennas and their testing. And then we talked a bit about the new proposed total radiated power standard from ANSI C63. That would allow us to measure antennas in a different way and make the testing a lot easier and quicker. Getting back to the cellular base station appearance, Mike Marcus was an advocate for that. He was a member of our group, and he was a big advocate for improving the appearance. We then talked to a group from a cell tower company, Crown Castle, and they educated us about how it's possible to make good-looking antennas, and not only possible, but they are actively involved in combining antennas into single units. So you get all your frequencies in a single unit that doesn't look too bad. And as we talked, we always kept in mind that as you're making your fancy-looking antennas and hiding them, you still have to make them maintainable. Because if something breaks, someone's got to get up there to fix it. You've seen these pictures before. They're ugly. And these are actually out in the world right now. But then we were educated that it doesn't have to be that way. It can be done nicely. And the question became, how do we convince the industry to do that? It's obvious, well, I won't say obviously, but it would appear to be much less expensive to put up the less fancy antenna. But who's going to tolerate that in their neighborhood? Crown Castle showed us some of the antennas that they're developing. And in this case, they have compound antennas in one canister. So it's not bad looking. And all the different antennas that have to be used across a cell site are all included in that one canister. They also did it in another shape. They could put about half as many antennas, but it's still a lot of antennas in a panel antenna shape. So before we get to our recommendations, just to let you know, we learned about other things besides just cells. We had one of our group members, who's also a researcher in this field, was talking about self-interference canceling antennas. And he's working on full duplex communication. So that's another way to make good frequency use by not needing two different frequency bands to talk in both directions. We had someone talk to us about fractal antennas, which is a very enticing topic, but did not appear to be too valuable at the current time. The plasma physics for commercial antenna development is being commercially deployed right now. Again, it didn't sound to us to be enough of a special topic to pursue any further. Adam, who's Drobot, who's another group member, who has a lot of experience in antenna modeling, gave us a survey of all the different methods that are used to model antennas. And then we talked to the group at Drexel University that developed spray-on antennas. And I think someday those are going to be very ubiquitous. We'll see them on a lot of people's clothes. They spray them onto material that tolerates being bent and twisted. And again, it's still in the experimental stages, but we would expect to see something out of that not too far in the future. Finally, we got into the idea of quasi-optical antennas. There's as much spectrum as we're using today is available in that higher range that's not being used, in the terahertz range. And this is a person who's studying it and how to use it, and there's a lot of good uses for those frequencies, but there are a lot of prohibitions to using those frequencies. We'll get into details of that. So Marty developed a watch list, which we all thought was a great way to clue the FCC in on what technologies we looked at and which ones they should be looking for as time goes on. MIMO is one that certainly is effective in improving spectral efficiency. The multi-element antenna arrays can be programmed to produce multiple beams simultaneously and tighten up the patterns. MIMO will be useful for improving both coverage and speed. Then it's an immediate impact. It's something we should be looking at right now. SDMA, Spatial Division Multiple Access, is a variant of MIMO, and it's effective in improving spectral efficiency also. It makes use of the multipath that exists and calculates in what that multipath is doing to focus the beam even better. SDMA uses multi-element arrays just like MIMO and uses local processing. We heard from one person who was doing this SDMA by distributing the antennas all over town and then having them communicate with each other about what they were hearing. And again, this is something that will improve spectrum capacity many times and can be effective immediately. Distributed antenna MIMO is more specialized, and even though it's somewhat theoretical, it's been tried, but we do expect that in some applications it can be used immediately. Antenna analysis and design is something that has evolved over the years. At one time, I think only the military did it on supercomputers, and today everybody's laptop can do some pretty impressive analysis and design of antennas. Obviously, the more you can do in the computer saves you test time later and test materials. It's very hard to test antennas. And over the next few years, we expect to see it get even more powerful. Filtering antennas, I talked about already, that they help to move some of the hardware out of the transmitters and receivers and into the antenna itself. And we would expect in the next few years that we'll see more of those. But quasi-optical was the exciting one because they're talking about designing antennas to work between 500 gigahertz and 10 terahertz. And again, that's a lot more spectrum than we currently use today. So if we're running out of spectrum, then we would certainly be able to go into there. However, that is also the area where there's a lot of scientific research being done, mostly astronomy research, that we would not want to interfere with. They're listening for very weak signals coming from light years away. I'm sure, especially with the Mr. Spock reference today, that's something that we would not want to interfere with. But with today's antennas, which are much different than the antennas that were available when the rules were written, we're able to focus these signals so well that we would not be interfering with those receivers. So we are we will be proposing a change in those rules. The quasi-opticals, just to give you a little more detail, their antennas are built into things that look like LEDs. They can be made with very tight patterns. And at those wavelengths, in essence, what they're doing is doing things that you do with light, like focusing, like lenses. You know, using a lens to focus something instead of just the way we focus the longer wavelengths. And they show very high antenna gains, typically 30 dB, and the side lobes can be as low as minus 50 dB. So now we're talking about the ability to focus so well that we wouldn't interfere with those things that need to listen to the great beyond. Metamaterials, again, I found very exciting. I think we all were excited by them, but we don't think it's a fully mature technology yet. It's not ready to be put out for commercial use, though there were some people who were trying. And hopefully we'll see some results from them, but we don't think that the technology will be fully mature for a number of years. The self-interference cancellation also is a method that would allow the full duplex communication, also something that is almost a holy grail of communications. If you want to make best use of your frequencies, that's one way to do it. And we think that that may be something that would be viable in the next 10 years. The spray-on antennas, again, we think would be viable in the next 10 years, but pretty fascinating technology for wearable antennas. The antenna itself is less than a micron in thickness, and so it's very unobtrusive. Fractal antennas, we thought was very interesting, but didn't really have much impact for us. And plasma antennas, likewise, interesting, but and there is a commercial development at this time, but we don't think it's going to advance the state of the art. So let's get on to our actionable recommendations. We are really have just a few small actionable recommendations. We started with dynamic antennas. Dynamic antennas, again, being versatile to precisely direct radiated energy to avoid interference, and that would allow more co-channel use of multiple users on the same frequency. As antenna heights become reduced, which is what's happening as 5G gets developed, and the radiated energy becomes highly focused, the potential for high energy densities on the ground increases. So that is something that we need to keep an eye on. We could be interfering with other services by putting too much energy on the ground below those antennas. The commercial use of advanced technology has matured since 2014 when the Commission last issued an NOI. And so we are interested, and we are going to recommend another NOI. The use of the narrow patterns at the high frequency bands may enable better sharing, and so we would also recommend looking at the rules that allow how much sharing, how much interference can occur at those frequencies. So our specific recommendations are to issue an updated NOI, and the NOI would specifically ask for input on modifying service rules and equipment certifications. Determine if the maximum power flux density limits that exist in the rules are necessary to prevent interference to other services. Obviously, if we can direct the signals well enough, then that maximum flux density limit is no longer an issue. And then the last thing we thought is that we would like to see an engineering study that examines the consequences and regulatory options of this technology. Clearly, no one person could give us all the details that we needed, and a group that was committed to studying this would provide us information that would go a long way. I'm not going to dwell on this, but these are some possible questions for this NOI that we can go over at a later time. But pretty much this is advancing the list of questions that was asked before to deal with our dynamic antennas today. Okay, the next recommendation is for smart antenna systems. These make use of signal patterns from multiple locations, as well as taking into account all the other things that affect the signal. Anything that affects the pattern, such as multipath, would be calculated in. So again, the FCC policies today are based on the possibility that the signal is just being sent out and could interfere with other things. If the signal can be focused, or in this case, calculated, to only appear at the personal cell or the site that it's being used, can we change the FCC rules and regulations to make use of this technology and have people incentivized to use this technology? Our next recommendation is related to the terahertz systems. The current FCC regulations prohibit all operation on some frequencies, mostly the very high frequencies, because of expected interference to passive systems. And the allocation table, footnote US 246, talks about that more. In the rest of the world, the ITU has recommended to give upper bounds of interference power at the receivers. Instead of telling you how much you can transmit, or that you can't transmit at all on certain frequencies, they're allowing transmission if you can demonstrate that you will not interfere, or you will not send more than a certain amount of power to those antennas that are doing this research. If those rules were changed from the absolute to something that was more measurable, then that would allow development at these higher frequencies, at the terahertz frequencies. The multi-beam, narrow beam technologies would, as we saw with some of the research, would allow co-channel operation with those astronomy research stations. So we recommend that the prohibition of co-channel operation on protected frequencies be replaced with a requirement that places a hard limit on all emissions that reach a protected passive terrestrial or satellite system. Finally, small cell appearance. We recognize that it's not really practical to come up with an FCC regulation to say we need good-looking antennas. But the FCC does have a loud voice. And if that loud voice, the bully pulpit, could be used to convince the industry that that's what they should be doing, it would be better for all of us. So the two things that we're going to recommend here are that the FCC issue a public notice to gather input from providers, citizens, and communities. Let's hear from everybody. We have heard from communities that are already making rules banning 5G antennas because they're worried about the appearance in their community. We've heard from just people who just don't want them around. And then, of course, we saw the evidence from our providers that it could be done nicely. And maybe these people don't know that. So in a public notice, we could get together all these diverse groups and try and figure out and let them know, let one side know that the other side exists, that it can be done nicely. And then the FCC could facilitate a multi-stakeholder group, not do it themselves, but at least bring together the different groups, the different stakeholders, so that they could create guidelines that hopefully would be recognized all over the country by the providers, by the communities, by everyone, so that the rollout of 5G would go much easier. And that's what we have. Thank you very much for listening, and we'll take any questions. Marty has a comment as well.
Well, I want to respond to the request that we talk about what we should do for the next year. And my comments, I think, are reflective of what our whole group does, but I got the microphone. So the first thing is that we do not suggest that we continue with the antenna group. We came up with some very good results, but they're more in the category of solutions, looking for a problem. We think that society has got some really serious problems that should be addressed by the FCC, and hopefully this group, with the enormous amount of talent that exists here, should be set to work on these problems. There is so much flexibility involved in the kinds of solution we talked about when you talk about signal processing and antennas, and there are trade-offs that have to be made, and the trade-offs are not all happening in the interest of society. And I hope people won't take an offense at this specifically, because I'm not aiming at any organization or company, but there is so much hype about 5G at the moment, and one would think that the only capability of 5G is gigabit frequencies, the low latency, and autonomous vehicles. Well, I can't think of any worse priorities compared to what the real demand is, because the reality is that the digital divide is getting bigger and bigger. It's becoming a digital chasm. There are 14% of the country, and I think that's a very low estimate, where there's no coverage at all. There are big segments of society that don't have access to broadband because it's too expensive. So it would appear to me that the higher priority and I'm not suggesting we don't need gigabits and low latency, but it's a much higher priority to get complete coverage, so you really can do things like autonomous cars, but so that everybody has access, and get the cost down, because a lot of the technologies that we talked about have the capability of huge decreases in cost. That's what happens. When you make things more efficient, they also get lower in cost. So my suggestion is that, and this is to you, Matthew, Dennis, and Julie, that we look for some serious problems and put this group to work on solving problems of society. Thank you.
Great.
10 cards.
Yes, so as is our habit, for those that have questions, comments, specifically addressing the antenna working group, or if you wish to respond to Marty's comments, which sort of fit with the 5G and IoT group later on, we can address those as well. So why don't we start around the table? Jesse, go ahead.
No, Dennis, and I guess I'd like to echo Marty's comments and support what he's saying, because I do think there's ways to build universal towers and universal antenna platforms to cover a whole wide swaths of spectral bands that we can address the 14% that Marty talked about, particularly in rural areas that are desperately in need of us delivering much more advanced communication services. And when you look at the work we're doing in software-definable networks, in terms of wireless networks, those are areas that I think will allow us to deliver new services, new applications to underserved communities, whether they be urban communities or rural communities. And I would recommend that what the antenna groups start to look at is how do we build antennas that cover the entire spectral bands, all of the bands, and design those as universal tower platforms that are available to all of the carriers, small and large, just that we can address the underserved where the economics don't work as well as they do in the urban and suburban communities in our country. So I just wanted to echo what Marty was saying and say that is something that I think in next year that all of us ought to start to look at how do we build the kind of thinking around that into our program. That's it.
Thank you, Jason. David?
Well, I want to actually sort of echo those comments, and particularly say I think communities are getting overwhelmed by a lot of concerns, including also concerns that that the equipment may be built out and abandoned, and they'll be stuck with it if things aren't built in some universal and shareable and reusable way. So I think that's a great direction and the sort of thing that, you know, perhaps TAC could do more looking at. I want to really echo Marty's broader concerns and happy to follow up with TAC members outside the context of TAC. I've been started at MWC a year ago, so well over a year ago now, about, you know, technology backlash in many, many different areas. Privacy is just one of many. I think this area is one where, you know, if we're not really careful to take these public concerns that Marty's brought into account and get the kind of input that I think both of you have suggested, I think our industry's at risk of considerable backlash, and this applies, you know, kind of both the industry here in the telecom case, but then in broader the IT industry as a whole. So I'm really actually thrilled to see this. I think this is, you know, kind of rightfully in the purview of the FCC and right at the intersection of kind of technology and what the regulatory body needs to work at.
Great. Thank you, David. Lynn?
Yeah. You know, in supportive of the rural efforts and rural areas that we work in, I do go ahead and second and third the universal platforms as far as for rural service. I think that'd be great as far as from an economic standpoint. The other thing I wanted to ask is, you know, as we're looking at these new antenna types with the additional power that's going to be beamed in particular directions, is there anything that needs to change or we need to be looking at as far as with maximum permissible exposure as far as MPE? Or do those rules kind of will still stay the same because some of this power output might be lower than what we've looked at in the past?
We actually purposely didn't consider MPEs.
Okay.
But I would think that the MPE is kind of a universal concept, is how much incident energy hits the body. So whether it's focused energy or unfocused energy, it's still a measurable quantity. So I would think that if you can focus and stay below the MPEs, then you're in good shape.
Okay.
Walter?
I just want to make a comment. Most of the TAC members know that shortly before his death, Vanu Bose gave a really great presentation to the TAC. He was sitting in my office to do that. One of the insights I got out of Vanu's presentation was that we really need to understand the cost of technology from the business model that's appropriate. He was focusing on costs from a small business model of trying to serve a very small population. One of the biases built into our system is that we often, and I'm guilty of this as an engineer, look at it from the perspective of the major market makers. And Vanu gave a very good presentation how costs that are insignificant in the context of serving a major metropolitan area become very significant when scaled downward and tried to apply to a low population, low density area. And I think we need to look at things not only from the context of how a Verizon or an AT&T makes money, but how a company that's struggling to serve a population that is low density in remote areas can also make money bringing all the technology that Verizon or an AT&T can bring to a major metropolitan area.
Thanks, Mark. Matthew.
Thank you very much for the presentation. I had a question about one of your specific recommendations. The recommendation that dealt with kind of changing the measurement in terms of protection of passive bands. Would you recommend at this stage that we would do a notice of proposed rulemaking on that? Do you think it's more suitable for an NOI at this point? What specific steps would you recommend the Commission take to implement that recommendation?
Not being very, as rulemaking astute as other people here, I think we do need to get the word out that this is a possibility, and hear back from the people who are trying to protect their research to see if they have any other complaints that we didn't think about. So an NOI would make sense to me.
Thank you.
Marty? Oh, okay. Go ahead. Dick?
What a great report, and what great work. I want to really congratulate the group on it, and associate myself with your comments, Marty. I think, and Walt too, because I think it's interesting, and I hope we can ask the future group to look at what it really would take to distribute broadband to the rural areas, to the unserved parts of the U.S. Because I think new technology, new business models, different business models, different systems could be looked at, and I think it would be a great contribution. Apart from that, I wanted to ask a very specific question. Marty, do you think that in one way or another we could recommend that in the U.S. we adopt the ITUR recommendations for the co-channel operation? Is there a problem with that? Could we issue an NOI and say, you know, basically we want to adopt those recommendations in the U.S.?
Yes. The answer is yes.
Well, maybe we could, as a suggestion, change your recommendations to carry it a step further. Would that, and again, I'm not very familiar with NOIs, but is that the subject of an NOI, or can it be done more directly? Anyway, thank you.
Oh, sorry.
We'll give you
give you an answer in stereo. I don't want to give you an answer off the cuff. I mean, normally what happens is following a World Radio Conference, we go back and look at what things we need to do to update to be consistent with the international radio rate. There are different kinds of rules that apply depending on the passive bands. Some of them say the limit is 0, which is some of them say all reasonable efforts. But we can take a look at this and see what is the art of the possible.
No, thanks.
Brian?
On the same subject, are the listening locations fixed and are they known? Will that be an issue? I'm guessing there are maybe not a lot of them. Do we know?
I believe that they are, yes.
Okay.
For listing.
The listening note.
The
one,
astronomy
listening.
the
Yeah.
locations we're trying to protect.
Yeah.
And second question, is there like a quick summary of why metamaterials are not quite ready for prime time? They've been kicking around some ways the theory is pretty understandable. I know it's an odd behavior, but what's the impediment to their commercial introduction?
The bottom line is that the theory is not very well developed. There are a couple of people that say they understand this, and yet the only manifestations that we see of metamaterials are people that have put stuff together and it works. They don't understand why it works. They can't explain it. They can't tell people how to reproduce it. So we're a little skeptical about whether it's such a broad subject about whether there really is a lot of usable science there at the moment.
Okay.
And so,
On the topic of ugly antennas, I just wanted to remind everybody about a company that went belly up called Metricom that introduced very small additions to streetlights and spent hundreds of millions of dollars getting approvals to deploy, managed to get deployment in only like 14 markets, partial, about 8 complete, and then basically ran out of money. I believe that the new carriers, even using that smaller footprints, are still going to have to face all of those local approvals and probably spend well into the billions in order to get those approvals.
Russ?
Yeah, quick question for the group in terms of, and by the way, ugly is in the eye of the beholder, and as engineers, I think we all have different opinions, what's good looking and ugly. I'm just kind of curious, though, when, we're on the verge of like a massive 5G rollout, and as, some of these millimeter spectrum, areas get launched or auctioned off, did the group look into how to potentially coordinate antenna sites between multiple carriers or ISPs in terms of placement? Because I'm sure that's going to be one of the challenges too for cities to have like, okay, every SP that comes into town has to have an antenna next to the antenna. And the other piece on the ugly side is not just the antenna, but you've got the cabling typically powering, all the pictures showed this very nice little antenna, but there's all the other parts, piece parts that were not really shown very much.
A couple things. First, Crown Castle did talk about, so they're a tower provider or antenna provider. So they did talk about providing a single site and having multiple customers at that site, multiple carriers. And that those antenna designs of theirs could be used by multiple carriers. Could be. That the rest of it, I think, is an economic thing. Your other question about the setup, we were shown fully wired installations, again, mostly by Crown Castle, where all of that is hidden. The wiring, even inside, most interestingly, even inside a wooden pole, they were able to disguise the wiring. And if you looked at our ugly picture, and I think most people would agree on that ugly, that even from an engineering standpoint, having loose wires hanging down, that's just a recipe for failure, for mechanical failure. And it also doesn't look good. So if you can dress those and make them less visible, that also makes them more engineering reliable. Marty?
Well, Russ, you're right on the mark, because the technology exists to do sharing, but there are already evidence of carriers trying to get a competitive advantage by going in and locking up a city and getting the town to give them the right to the light poles, as an example. And that could be a serious problem if they end up eliminating competition, because competition is what keeps our industry going. So this is one of the potential problems that we could look at. And as long as I got the microphone, I'll finish my other comment. Jesse Russell made a really important comment to me. Several people have been supportive of my comments about unserved markets being rural areas. The unserved markets in the inner cities are equally unserved, equally unavailable to people, and a more serious problem even than the rural areas. So we really have to think about, when you talk about important things like education and healthcare, we're not going to be able to withhold broadband from anybody. And that is a crucial problem that we have to address for the future.
David?
Since a particular company's name was mentioned, I feel compelled to say that that particular company is in at least one instance explicitly not trying to install facilities to be used by multiple carriers, and they're specifically trying to install facilities for a single carrier. And the facilities that they're trying to install are not, proposing to install, are not as compact as the ones depicted. So different information is, I suspect, being provided to the TAC, or at least to your group. It would be good to get these things on the record, because I think these are not the things that they're actually going forward with when they address communities.
But perhaps they could if we're not pursuing.
They certainly could. I'm just simply pointing out the value of getting these things on the record.
Yep. Nomi.
I'm just wondering, as I was listening to this discussion, I hadn't thought about this initially, but as I listened to it, it feels like from a technology standpoint, there could be some parallels between what the FCC did structurally to address one-touch make-ready and what we're talking about here. You know how the structure of one-touch make-ready leaves the states where they have two options where to regulate utility poles. They can either pass legislation recognizing the right of the FCC to regulate their utility poles, or the states can form their own regulatory agencies to do that. And I guess I just wonder, from a technology standpoint, do we think there are parallels and of that kind of structure, and could that help us here?
I don't know what that is.
I just have a passing knowledge of what one-touch make-ready is. But is that more of a legal question or a technology question?
Yeah, I know. It probably is legal, but I was trying to think of it from a technology standpoint, like how similar or different would that be structurally? Like, would that give us some guidance for how we might address the concept? Yeah.
It seems logical.
Mhm.
But I don't know what all the
Yeah.
federal and state law implications are.
Mhm.
Yeah, put something like that. So, yeah. Yeah, they usually don't charge the engineering office with answers to legal questions. But just a few thoughts. All of these comments are terrific to hear about, and maybe, because we're going on a bit, hearing a little bit about how the technology of the antennas solves some of these problems, making that link between the two. What is it about the antenna technology that helps solve some of those coverage problems in the rural areas and the unserved? Just a little different angle, and it was touched on, I think, in the presentation. So one is the whole testing issue, in our equipment authorization program, where we often have some latitude in how we do the testing. And I go back to when you've got a device and it's got for the longest time on what we think of as the license side, you had an antenna port. And so you'd connect to the port, you'd measure the power, you'd measure the out of band and the spurious emissions, and you were done. And as the antenna technology is being integrated with the devices, there is no port. And so we get into things, what the staff wrestles with. We have technical standards on the books, and now you've got a product that not only is it multi-band and multiple technologies, and if you really mapped out all of the combinations, you wind up with saying, gee, we'd have to test this 2,000 times, and that's completely unrealistic. Now I couple it with an antenna that has got a lot more ability to steer signals and the gains and so forth, and filters. And it becomes, how do we deal with this in a way that ensures that all of the steps that are put in place to control interference are maintained without building up so many tests at so much cost and so much delay that we're impeding the introduction of the technology. And I think just two other points related to this. One is we've focused a lot on the in-band performance as we move to these antennas, but not as much as all of the discussions we have about out-of-band and spurious, and trying to understand, well, what do I do now? I've already tested it. We don't test things 2,000 times, but I've already tested it, let's say, 10 times in band. Now do I have to do the same thing all over again and looking at the out of band and so forth in the spurs? And I think, just my personal observation is the technology is running ahead, which is terrific, but I'm not sure that the community really has gotten its arms around about how do we take advantage of these things for the interference control. So for, the way we've thought about things in the past is here's a static antenna, it's got a radiation pattern and back lobes and so forth, we do the analysis. Now we are reaching a point where with the antenna technology, I can notch out a sector, I can reduce the power in that direction and so forth, and I think building the confidence of the community as to how those things can be taken advantage of, well, we still have a ways to go. So just some thoughts. I think it's terrific, but having it integrated into some of the other things that the Commission deals with regularly, the out-of-band emissions, spurs, and so forth, and trying to figure out how we apply these to the newer technologies and how it solves some of those problems. So the idea of an NOI maybe is a vehicle to start teeing up some of those things. So I've generated a lot more cards.
Let me respond.
So as long as they're answers.
Keep an eye on filtering antennas.
Yeah, absolutely.
And in metamaterials, they were also talking about designing a metamaterial antenna that had built-in filtering.
Yeah.
Julie, we never said it was going to be an easy problem. It's going to be
this is a fun problem because it holds a promise of solutions. And it's like, well, how do we advance it is really where I was getting at. How do we take advantage of these things? Not from the regulatory, but how do we bring these things about?
Yeah, I just wanted to point out to you that the energy coming out of any one port in one of these massive MIMO antennas is infinitesimal.
Right.
The only place there is energy, if you do it right, is right at the user. Well, I don't know how you do that.
Right.
But
my comment really goes, I don't know that the community really understands this yet.
Yeah. Well, that's part of why you have a TAC.
Yeah, absolutely.
Jesse?
No.
Sorry. We're still doing wired here.
I just wanted to react to Julie's point. Maybe it's time for all of us to start to think about work that was done many years ago in terms of unbundled network elements. And there was to reduce the testing aspect, but more importantly, to create more uniformity in how you might design the front end of this, which is the antenna platforms. Which is what I was talking about earlier, is that the direction now seems to be moving more toward software-definable infrastructure. By pulling these elements out, you can reduce the testing because you're testing only an element of the entire network, and you're not restricting the spectrum. What we've done now is that, what we're doing now is we're decoupling the spectral bands, and I'm saying maybe we shouldn't do that. Maybe it's time to rethink that whole process and look at the antenna and the spectrum as a element of the network, given that we're moving toward hopefully unwiring America. I don't know if we're going to get there, at least not in my lifetime, but I do believe that we ought to go back and look at a lot of the work that was done with unbundled network elements many years back and try to see how do we apply that to wireless communications.
John? If you comment and then go directly into your presentation.
Sure. Just a follow-up to Julius's note about testing. These new antennas don't just have statics, they have dynamics.
Yeah.
And so I think when we start looking at out-of-band spurs, for example, or out-of-band emissions, we have to look at whether they generate a temporary noise spike out-of-band while they are changing from
Right.
mode A to mode B.
Right.
An even harder testing problem.
Yeah.
Thank you for making Julie's already difficult problem
Yeah,
worse.
no, you couple it with, and I'm sensitive to it, it's like, okay, I can run it in 1,000 different ways. One time out of 1,000, it was 2 dB over the limit. What do I do with this?
Yeah. Very good. Thank you so much for all the work, both for the chairman of the antenna group and for the entire antenna group, and for the additional conversations that you generated, Marty, with your final comments too. So with that, we do transition to the UAS working group. And John, please take it away.
Yeah, very good. Could we have the slides, please? Very good. So good morning, everyone. So this working group was charged with looking informally at spectrum for UAS. Our formal title was Communication Strategies for Unmanned Aircraft Systems. We were fortunate to work with a number of FCC liaisons who are listed there. We had 3 fellows stepped up to serve as chairs of subgroups from Intel, AT&T, and Ericsson. Then we had substantial contributions from the 4 folks listed there, and then ongoing discussions with everybody in the right-hand column. We had a number of briefings that are listed here. We also were quite fortunate to have substantial participation by subject matter experts coming more from the UAS side of the house, several of them, than from the traditional FCC member communities that are more strongly represented here on the TAC. So we're grateful for their contribution and for the simulation studies that are listed there. So we'll be using the term UAV for unmanned aerial vehicle, UAS for unmanned aircraft system, which includes all the other components of the system. You'll hear me talking about C2 for command and control, and CNPC, command and non-payload communications, which is considered to be the stuff related to actually flying the vehicle as opposed to taking advantage of whatever functionality its payload provides. So the next 2 slides describe the priority topics that were given to us early in our work year through a meeting that was held at the FCC. Under the broad topic of studying the spectrum issues for UAS, we were given a number of specific questions, far more than we could possibly address in 1 year of work.
Fair, we usually give more actionable items than
That's right. So wonderful questions, very important area because the UAS market is growing so quickly, and the FCC is really quite interested to assure that it facilitates as opposed to impedes the growth of something that may offer both high social benefit and high economic value. So I've listed all of those priority topics on the last slide and this one. And we ended up choosing to focus on a small subset of that. We chose to focus on terrestrial mobile bands and systems, the use of those that spectrum and those systems for supporting UAS operations. We recognized that the full picture of support for UAS operations must necessarily include also satellite and unlicensed bands heavily, as they already do. But we were not able to look at the potential implications of that or potential FCC actions. So those would become a 2019 work item, among other ones, which we will address again as our last slide. The other last note before we get into our content, in the interim between the December meeting that was unfortunately canceled and this rescheduled meeting, we did note the arrival of the Reauthorization Act for the Federal Aviation Administration. And in 374A3, it directs 3 agencies, including the FCC, to submit a report by July 2nd of this year, including a number of things related to UAS operations, one of which has to do with spectrum frequencies. The specific text is, what are the other spectrum frequencies that may be appropriate for beyond visual line of sight operation? And the other in that sentence refers to other than the recommended bands from the World Radio Conference, which are 960 to 1164 and 5030 to 5091 megahertz. So we note that in the briefing deck that you have in front of you, there is information that is relevant to the report that the FCC is required to submit. In specific, specifically our analysis and conclusion about 3GPP technologies that they satisfy the communication requirements for low-altitude UAVs. That does include concluding that they satisfy the beyond visual line of sight communications requirements under certain conditions. And we also did provide an analysis of the availability of other bands and their regulatory conditions for UAV use. So hopefully that will be relevant to that statutory requirement. So the way we chose to organize this briefing is we are listing our recommendations right up at the front, and we're going to step through them. And as we step through them, we will highlight in bold each piece of the recommendations and then provide the supporting material that leads to that recommendation. So we have two overall recommendations. Recommendation number 1 states the FCC should consider UAV access to terrestrial mobile bands, along with corresponding service rules and associated technical parameters, taking into account FAA regulations governing their use by UAVs. So I'll talk to this overall recommendation first, and then I'll talk to the detailed sub-recommendations that go into it. So this chart was prepared by Reza Arefi of Intel. He would have briefed today, but unfortunately was not able to join us. But the whole group did concur with this. This is a high-level analysis of the amount of spectrum required per UAV that is operating if you are using the 5G technology, the IMT 2020 technology. A key thing to note is that the numbers used in developing this chart are the minimum performance requirements for an IMT 2020 compliant radio system. So one would actually expect that the amount of spectrum required would be somewhat less than this with an operational system that had a correspondingly higher efficiency. But at those minimum levels set by the IMT 2020, which are over at the left, and then making some assumptions about the amount of throughput that is required to support different operations, you can generate a chart that looks like this. The highest pair of lines, blue and red on the chart, are the high rate, where you might be doing, for example, an HD video downlink. And then the lowest pair of lines on the chart, the low rate, would be corresponding to what you would see perhaps for command and control only communications. And you'll notice that the amount of spectrum required to support a single operating UAV varies wildly. That is a log scale on the left-hand side. Varies wildly as you go from the peak efficiency close to the cell center out to the cell edge. So that's one data point. It's going to lead to our recommendation, which is that one needs to consider multiple separate bands. It would not be efficient to designate a single band for doing this function because the requirements vary so wildly. Similarly, we did an analysis covering all of the designated terrestrial mobile bands, looking at the spectrum availability and the regulatory conditions. We particularly noted whatever regulatory conditions may restrict aeronautical operation. We provide the full details of this analysis as an attached Excel spreadsheet, hopefully useful for the FCC folks. For anyone who's receiving this document as a PDF, the last 3 slides of the briefing deck are a PDF printout of the spreadsheet, so you have all the information available as well. Not to go into all of the details, but rather unsurprisingly, one again notes a significant variation among the bands, even to the point, the fact that some bands used for terrestrial mobile operations have an explicit restriction preventing aeronautical mobile operation, whereas others do not. So given those observations, there are potentially high spectrum requirements, particularly out at the cell edge. Given the wide variation in available bandwidth of different bands and the significant differences in their regulatory conditions, it was our conclusion that identification of a single band or a small subset of the terrestrial mobile bands for UAS use would not be prudent. The FCC should consider permitting or supporting UAS access to the whole collection of terrestrial mobile bands, and that was what we intended to recommend in the language of our recommendation. So going on into the detailed support for this, the first part of the recommendation is that when considering use of the bands, the FCC should consider issues of potential in-band and out-of-band interference to terrestrial or aeronautical incumbent services, enforcement challenges, and what harm claim thresholds to apply. So I have a slide on each of these. The key observation, and I did share this with the TAC last fall, so folks have seen this from September before, is that the operation of a significant number of UAVs would change the status quo in these bands, which was the basis for the current interference analysis. It significantly increases the expected number and density of flights compared to current aeronautical operation. And it changes the assumptions that underlie previous regulatory decisions. In terms of in-band interference, we note that even a low UAS operation, say 400 feet, exceeds the antenna height that was assumed in many of the band studies for where the mobile devices would be located. We note that tall buildings can exceed 400 feet, but those are relatively geographically rare, and most deployments in most of the country can largely ignore buildings higher than that altitude. So we also note that there are 100 miles per hour vehicles. But under Part 107, there may be many UAS that are both 400 feet high and 100 miles per hour at the same time. And that was likely not a condition that was considered other than an extreme edge condition in any previous band studies. Looking at out-of-band potential interference, we note that there are cases where these terrestrial mobile bands are adjacent to noise-limited services, not only to interference-limited services. And all those studies related to out-of-band emissions and out-of-band receiver sensitivity likely assume that the dense number of transmitters were down in the ground clutter, a condition which would no longer hold when you elevate lots of them onto UAVs. So we're not saying that this rules out use of terrestrial mobile bands, but these are technical issues that do need to be analyzed. And one that might become a 2019 work item. This is one of the things that we recommend continuing the group to look at. Going on to enforcement challenges, we note that when interference does arise, it will often be of very short duration and it will vary over time. So this is a case where the traditional approach of wait for a complaint, send your van out with a directional antenna and try to locate the interfering emitter would clearly be ineffective. So new approaches are required there. Oh, I'm hearing about a new technology called a fly swatter. That'll be fun.
Oh, don't get us started about
And in particular, I think the thing that is really quite relevant for the FCC in the near term would be if the FCC is to try to facilitate rapid growth of use of the terrestrial mobile bands for rapid growth of the UAV market. What conditions must be true about a band in order for transmission from UAVs to be authorized without a detailed study? I think that is a very interesting question that could perhaps offer some high benefit to accelerating growth. Similarly, question on a device certification side, will existing transmitters be compatible with airborne UAS operations? Hopefully the answer is yes, but it does need to be looked at. And if it's not the case, what additional conditions, features, or capabilities are needed in the devices to assure that they are compatible with those airborne operations? And the third part of our detailed recommendation was that harm claim thresholds require study. So I'm going to use this same setup on 3 subsequent slides. Let's hypothesize that there are 2 licensees, each of whom has a terrestrial mobile license. Licensee A and licensee B, they are geographic neighbors. And we're in a situation where they both have terrestrial operations, and let's hypothesize that licensee B is the victim in all 3 of our slides here. And we're looking at the case where you have a terrestrial transmitter from licensee A, existing receivers from licensee B, and you're in a situation, status quo ante, where there is low interference. Now, licensee A chooses to start operating a number of transmitters on UAVs. And so I'm showing that in red. Those are the new transmitters. And it turns out there is increased interference to the existing receivers of licensee B. Under what conditions may B seek FCC protection from this increased interference level? Or is it just their responsibility to tolerate it because this is a terrestrial mobile license in both cases, and it extends to UAV operation? So that's case one. I think this is the case that everybody is thinking about. But we identified 2 additional cases that need to be considered when considering a heavy use of the terrestrial mobile bands by UAVs. So case 2 is the case where, again, status quo ante, there's low interference, everybody is happy. Licensee B starts deploying its receivers on UAVs. Now it's getting interference from licensee A. May it seek FCC protection? Interesting question. And then we get on to license case 3, which is even slightly more subtle. So this is a case where licensee B is operating both terrestrial receivers and existing UAV receivers. Licensee A has terrestrial transmitters, and everything status quo ante is fine. That's the far left case. There's low interference in both directions. Now licensee A puts in a new transmitter or modifies its use of its license and is still causing only low interference to the existing terrestrial receivers of licensee B, but is causing increased interference to licensee B's pre-existing UAV transmitters. Can licensee B claim protection from the FCC and require licensee A to change its behavior? These are all interesting harm claim threshold questions that are going to need to be considered before we get too far down the path of mass deployment of UAVs in these bands. So that's the end of subpart A. Subpart B recommends that the FCC collect data from studies done by industry, FAA-sponsored projects, other government agencies, academic, and foreign entities. There is quite a lot of relevant data available from various stakeholders in the UAS market. We note that their FAA is running the integration pilot program that should be generating interesting data. We note there's ongoing private testing done by vendors and operators. Government agencies such as NASA are running studies. Academia. We've learned in our group about various foreign entities that are testing 3GPP technologies. Actually, there's a full report from the European Commission on behavior in the unlicensed bands. That's very interesting. But we also observe that all of this available data is not well organized to support the FCC's spectrum regulatory needs. And not only is it not organized, but it can be very difficult for a non-specialist to assess the quality and applicability of the data. Little of that literature has been peer-reviewed. So it seems that both the FCC and the UAS industry would benefit from formal collection of data, perhaps via a notice of inquiry, and from organizing and annotating that data. This could also be a TAC work item for 2019 or an FCC-sponsored work item. And some of our membership noted that there's some benefit to the FCC taking this on because some of the data that would be of high interest folks might be willing to share on a government eyes-only basis, but not be willing to share with their competitors on the TAC. And maybe a strategy discussion to be held there. Third part of recommendation 1, we are recommending that the FCC reassess any service rules that prevent integration of UAV communications functions, for example, command and control or payload functions, into shared data links. This is because we observe that the technology exists to perform multiple functions within a single data link. That might be called resource management if you're doing it within a shared physical and MAC layer. It might be called slicing if you're doing it with differentiated physical and MAC layers. But whatever term is used, there are good technologies for being able to do this. And there are significant drivers in terms of reducing weight and power consumption on board the aircraft that you would like to do this. So this radio interface sharing would be expected to improve spectral efficiency while reducing aerial system cost, weight, and power. The FCC should not preclude it inadvertently through interpreting these functions as belonging to different services and requiring them to operate in separate bands. So that brings us to recommendation 2, and I'm going to turn the briefing over to my colleague here, Stephen Hayes from Ericsson, who led this part of the work.
Okay, thank you, John. In this part of the study, what we focused on was what systems could satisfy likely requirements that we would have to support a UAV. And so I'll go through the different recommendations that we have here and talk about how we came to the conclusions that we did. Okay, so in doing this evaluation, one of the issues that we faced was that we don't really have concrete requirements for what the communication capabilities are needed to support a UAV. So we tried to gather some likely requirements as best we could using sources like the Aviation Rulemaking Committee from the FAA or the Drone Advisory Committee, and you'll see those reflected in these documents. When you talk about communications toward a drone, people quite often think actually just about the command and control, but there are actually several different modes that we'll talk about that are used for things like the control for the payload, for tracking the system, etc. In addition, when considering it, we also looked at different aspects of communication, such as the reliability, the security of the communications, how well you could integrate it, latency, the deployment issues, etc. And if we'll just be providing the summaries here, but I think starting on slide 38 of the deck, you can find a lot of backup material that supports the conclusions that we reached. Okay. In evaluating technology, there's a lot of different aspects that could be considered. To attempt to sort of categorize the aspects, we used some tiers that were developed by the Aviation Rulemaking Committee. And these include tiers that sort of relate to how far away the drone is from the operator. So how far you need to be able to transmit or receive information. There's a tier 0, which is basically within 400 feet. And then there's a tier 1, which is beyond visual line of sight, which is under 400 feet, but farther away. Actually, no, that's still visual line of sight. Sorry, my eyes aren't working that well. There's tier 2 that's beyond visual line of sight, but could be higher than 400 feet. And then there's tier 3, which could be in controlled airspace where planes would be, which would be higher up. So these are the tiers that we used in trying to evaluate which systems and standards would work. As John mentioned, we only had a limited amount of time, so we picked one technology to look at initially, and that was the 3GPP suite of technologies. Others, such as Wi-Fi, ADS-B, unlicensed bands at 900 megahertz, those are slated for future work if we can get around to it. Much of this analysis was based on a study done in 3GPP. It was one of their most heavily documented studies on the use of drones in LTE. So we based much of this analysis. For the different communication modes that we looked at command and control, primary, the possibility of backup command and control, the payload, separation avoidance, which is communications used to keep drones from running into either each other or into fixed objects or moving objects. And then 2 that are related to security, which are broadcast ID and network tracking that form the remote ID suite. And these things have to be figured out before, I think, the beyond visual line of sight limitation will be removed in general for these. So as long as the remote ID issue hasn't been handled, there's kind of a hold on the removal of a lot of restrictions associated with drones. So these are the different communication modes that we looked at. under the different tiers of how far away they are. And basically what we found is that 3GPP technologies are able to satisfy all of these. Now, this isn't necessarily the same 3GPP technology that you see on your cell phone. 3GPP technologies support different classes and qualities of service, and it could be for some of these functions that require higher reliability that you would use higher classes of service to ensure reliability. In addition, this also, for some things such as the remote ID, which is being broadcast, or network tracking, those requirements are not yet established. So although the underlying capabilities exist within 3GPP technology, the specifics of supporting those haven't been done yet because the requirements haven't been finalized. But overall, the 3GPP technologies were found to be adequate for addressing the expected needs of low-altitude UAVs. And when I say low-altitude UAVs, those currently are UAVs under 300 meters, because that's as far as the studies went in establishing the capabilities. And then all those things on the right that says not yet evaluated, hopefully those will be addressed in future work of the UAS group. Okay, so recommendation A is recommending that the FAA consult as appropriate with the FAA and other groups regarding the use of terrestrial mobile bands for UAV communication. So we weren't quite sure what the appropriate wording here was, but basically FAA or FCC to work with whoever's necessary to consult with the FAA as necessary to allow the FAA to do whatever regulation is required for use of the terrestrial mobile bands for UAV communication. Okay. So this is basically just repeating what I said, that we encourage the FCC to work with FAA and other organizations to minimize impediments to utilization of suitable communication technology, maximize the benefit from using already allocated spectrum and infrastructure, and also the global harmonization of regulations for UAS communications. And I would note that in other parts of the world, there is similar work going on the adoption of cellular technologies for use with low-altitude drones. Okay, recommendation 2 thank you. Recommendation 2 refers to something John already indicated, that especially with terrestrial mobile bands, there are in many cases prohibitions against aeronautical use. So let me pull this down here so I can see. So it's this chart, which is probably not visible for people in the audience, but it indicates several of the mobile bands that have been proposed or that are being used, and the fact that there are different restrictions on different bands. In many cases, when I think these restrictions were developed, they were thinking more in terms of aircraft as opposed to low-altitude drones, which have a different profile in terms of interference and the impact that using those bands would have with those devices. So one of the recommendations then is that the FCC would reinvestigate those restrictions and adjust if necessary if they're preventing usage or inappropriately preventing usage in drones. So, and I believe that is the end of the recommendations on this part. So I'll turn it back over to John. Thank you.
Okay, thank you, Stephen. So just to wrap up quickly, this is a repeat of all the recommendations, which we've read out loud, so we don't need to go through them. Slide, and then there's recommendation 2 as well. And so here's our final slide. We did identify a set of work topics for 2019, which we've already been referring to. That initial stakeholder priority list from 2018 included a number of really interesting topics related to how radar might need different spectrum or how that should be adjudicated, issues about dealing with rogue drones and where the FCC should be acting in that area. So we certainly would be delighted to study any of those additional items. We noted on slide 15 the potential for work on recommending methodology for assessing potential interference. We noticed on slide 16 enforcement challenges. We could work on that as well. We noted the interest in collecting relevant data and then analyzing the results through an NOI. We are certainly very interested to evaluate systems and standards other than the 3GPP technologies. And we could also be tasked to look at alternatives to the current aeronautical restrictions. So we look forward to the FCC's guidance on that for next year. Thank you.
Great. Thank you, UAS team. Now, opportunities for questions and comments, and Brian is first up.
Just quickly, was DJI part of your group or not? Did y'all get input from them?
We had a briefing, but they were not a part of the group. Thank you.
Other questions or comments from the group? There. Paul.
Thank you, and thank you, John and Stephen and the whole group for all the work you did. I think you've come a whole long way. If you remember about 3 or 4 years ago when we first started discussing this topic, there were a lot of folks who were saying, you know, we need to find protected aviation spectrum, dedicated spectrum, and this clearly is not the case. And so thank you for all the work that went getting us to that point. Just want to point out 2 things about your report. One, I think, is fairly obvious, and that is chronologically, the FCC and others, including perhaps this TAC, should be gathering the information, the data about potential interference before assuming there is potential interference, that there actually is a problem that needs to be addressed. And so hopefully that data gathering will come first. That's really obvious. The second thing that may be less obvious for those of you who don't live in this world day to day, and that is that that one of the things that this group did not spend a lot of time on was distinguishing among the different safety cases for the use of UAVs. The FAA, of course, is very focused on this kind of distinguishing between things like RPAS, which are sort of fly-by-wire. You have a pilot looking in or working with a drone that's far away, perhaps over the horizon, but is piloting it. So the communications link is essential to the safety of the operation. At the other end of the spectrum, as it were, are fully autonomous drones that do not rely on the communications link for safety. They may require it for the mission criticality, but not for safety criticality. And a colleague of mine likes to point out the analogy to a horse. If you want a horse to get into a barn, you need to communicate with it, and if that communication breaks down, the horse likely won't go into the barn, and therefore the mission is a failure. But the horse will never run into a tree. It just won't do it, ever. And so there's not a safety concern with the loss of a communications link to the horse, just a mission concern. And so that kind of distinction among the level of sophistication of the vehicle has not really been taken into account in this group. But I think with the availability of the studies, the look at the data that's already out there, that will be one of the first things that I'm sure that the FAA will be looking at. Thank you.
Yeah, let me just say to Paul, to thank you to you and your team at Amazon for sending Sean Cassidy to support us as a subject matter.
An actual smart guy.
Yeah, we had a wonderful participation from a subject matter expert from Amazon Prime Air and contributed tremendously to the group. So thank you for that.
You're welcome.
And thank you for the comments.
Thank you. Yes, I think it's very true that there are different mission profiles, many of which would require highly reliable communications, others which wouldn't. And that was actually one of the advantages of the of the cellular communication, given the fact that we have such a diverse set of mission profiles and different levels of automation. It's not clear exactly how much latency you can tolerate, how much reliability is required in different scenarios. And one of the advantages of using cellular communications and technology such as that, where you're able to adapt your system dynamically by either using more spectrum at times or using more resources, it gives you the advantage of being able to handle these diverse situations. I think when we look at some of the other technology, it's going to be more challenging to figure out exactly which niches they fit into, because many of them will have more strict limits on the types of latency that they can tolerate or latency that they can provide or maximum bandwidth that they can provide. But it is very true that there are a diverse set of safety and communication requirements that UAVs will have to be able to support in the field.
Totally agree. Thank you, Stephen. Mark? Yeah, on to your recommendation on 2 and 3 on the methodology of assessing potential interference and enforcement challenges. One of the things that you mentioned was it happened so quick you can't just send out an FCC radio van to try and figure out what happened. And it also, to tie back into the beam steering antennas and other things, those antennas are now, they're completely different from like typical antennas as well into this. Is that typical antenna, if it would get the beam were to interfere with something else, it was typically that the antenna moved, or there was some damage to it. But now we have the beam steering antennas. We now have, it brings a lot of potential, and as it ties into the UAVs, it also brings the possibility for more points of failure, because the beam can go in the wrong direction. There's all types of other things that can happen. So you've got more possibilities of interference. So it brings us back to where we need to get to more of a real-time monitoring situation, to possibly the carriers or the people who actually have the antennas deployed, to where you can get real-time feedback as being required into the deployment of the equipment. So you're actually getting feedback from what's happening at the antenna from the transmitter and receiver in real time. And that's just a suggestion.
David? Boy, this has really gotten me thinking about the FAA's potential to use UAVs in so many ways, and the FCC's potential, to use UAVs in so many ways. But and I do need, I'm sorry to take people's time, but I just got to comment on the horse analogy, which is the horse will not run you into the tree, but in my experience, if you're driving a sleigh, it will wrap you around the tree.
I want to hear more, David. That is your experience, right?
Sorry. And that is probably because I did not grow up with horses and sleighs. I learned it late in life. The question I have is actually a really first off, I got to say, you folks just had way too much technical fun with this, as I think did the antenna folks. I'm really impressed with the detail. Real specific question on I'm afraid it's a nit of the wording on the proposal that we're good on the low altitude. Does that include within the controlled airspaces? Because the FAA sort of seems to, I just checked their language. They sort of have low altitude inside and outside, and you can get permission to take it into the controlled airspace. So we don't even have to do it now, but if you know the answer, that's great. If not, we should just get the wording exactly right.
Yes, we probably need to address that wording. In the actual analysis that we didn't actually look at the airspace considerations, because we were looking more at sort of what the interference level was and whether the communications would be adequate. So, and those things don't change depending on whether you're in controlled airspace or not. So we view the issue of how you behave differently in different airspaces is more of an FAA question as opposed to an FCC question. So for our analysis, we aren't really making that distinction, even though we realize that certainly the FAA, when it decides on what's appropriate, it will certainly make those distinctions. But yes, if you can point out some specific wording we need to change, I think.
There may be an asterisk or something.
Paul, do you want to respond?
I did. Michael, do you want to go first? I'm sorry, Michael. Yeah, just to David's comment, and it's not about the horse, but about the controlled airspace. Obviously, the controlled airspace goes to 0 in some areas, but these tests that were done, including tests that have been done by Amazon, go up to, say, 2,000 feet, which is well into, quote, controlled airspace in many areas. And so that's part of the safety case that the FAA is going to be putting together. And the FAA's safety case, again, will look to the sophistication of the vehicles and whether or not they truly are autonomous, whether they can have safety-critical functions handled in the drone itself versus the ones that are remotely controlled. And so that's part of the safety case consideration. It really shouldn't or isn't part of the communications link discussion.
Thanks. Great work, John and Steve. So just a couple of questions that, if you look at the licensing models of all the terrestrial bands you cover, it ranges from counties to PAs to, BTAs, and EAs, and some we have a nationwide license. Given your interference analysis, does the working group have a view about the size of the licensing model versus the interference impact?
Great question. We did not consider it.
Okay. So maybe something that we can think about.
One more item for this year's work. Marvin?
Have you looked at all at the spectrum implications of the additional radar that's going to be needed for detecting malevolent drones over stadia, prisons, controlled airspaces, and so on?
We actually discussed that early in the year as an item of very high interest, but did not have a chance to look at it.
Yeah, just wondering, if for the next round, how feasible it might be to try to boil down what bands might be the most potential for this application. And I'm reacting a little bit to what Paul said about let's not assume there's interference going, but there's some of these things that I can look at right off the bat, and I know that there's probably going to be problematic, and it's probably not even worth raising. Just for example, a WCS band sits next to the satellite DARS band. You put it in the air, and it was tough enough as it was to try to figure out how the sharing would occur. There's another AWS band where, because it's adjacent to federal satellite spectrum, there's an out-of-band emissions limit that's much tighter than anywhere else. And so it's something to think about, not trying to take things off the table, but sometimes it's easier, you look at some of these and say, yeah, that gives us some capacity, or look, this wouldn't be worth it even if we could figure it out.
Okay, great. And just for the record, I do concur with Mark very much about the importance of advanced monitoring and enforcement mechanisms. It's a horn I've been tooting for a decade or more, so thank you for bringing that up, Mark, and it certainly applies in this case. Yeah.
Stephen?
And I just want to indicate, in addition to what Marvin indicated about ground-based radars that may be intended to protect against malicious drones, you also have the issue there may be some sort of radar sonar on drones itself to keep them from running into things. So
Like
you
trees?
also have that. Yes.
Or horses, yeah.
You haven't been away long enough. We're
Marvin,
thinking
are you-
the same thing.
Okay, great. All right, with that, amazingly, we're running 1 minute ahead.
That was our job.
And lunch has already been set up, so please take advantage of lunch. And while you are enjoying your lunch, be sure to thank Kevin Luddy and Charter Communications for providing our lunch today.
That's great.
Also take advantage of the table, and those of you who might have memorabilia that you have not yet placed on the table, you can feel free to do that.
Good job.
We do have a busy afternoon once we reconvene. We'll start out immediately with computational power stress on the network. And Russ will be doing double duty, taking on that one as lead. And Lynn, you're going to also contribute to that. And then Russ and Brian over the phone will cover the 5G and IoT, and we'll close out with mobile device theft prevention with Melanie, leading into our 20th anniversary celebration. So that's the course, and please enjoy lunch, enjoy the conversation.
So what did you say what time we're reconvening?
And we'll reconvene at 12:45. Also, make sure that on a personal note that you have an opportunity, if you've not already, to express your thanks to our past designated federal officer, Walt. So this would be a good time to do that.
Thanks, Walt.
and you can note how relaxed he is. Okay, so Russ is here, so now we can start. Not highlighting
I
your
don't get a
absence.
break for 2 presentations, so I figured that would make sense.
Hopefully you did enjoy your lunch, and again,
They have submitted it.
thanks to Kevin for providing it. And now we're on to computational power stress on the network.
Okay, good afternoon, everybody. This is the after-lunch lull, typically, but we're going to keep it exciting. So first, I wanted to express from both Adam and Lisa, they're very disappointed they can't be here today. They really would have liked to have been here. They had conflicts, obviously, that they could not make it, so they just wanted me to pass that along. Next, let's get to a couple of the slides here. So,
Did you have something else that you wanted to do first?
No, that's next presentation.
Okay, very good.
Thanks, though. So in terms of the members in this working group, a good cross-industry group with excellent insights and experience in the market in terms of the transformation that's taking place, and we're going to talk about that. So let's see. So this group is called Computational Power Stress on the Network, which sounds very ominous. However, in general, it's a positive impact that the team explored related to big data, machine learning, deep learning, artificial intelligence, and services such as VR, AR, and the computation that's driving the network change and the transformation in architectures. The data impact on the network continues to grow as these capabilities become more mainstream and accepted and used. So the key question the working group work to provide answers to is how do all these technologies affect the network as we know it, the evolution and the potential transformation, and what the FCC should do about it. We got 2 things here to move. Okay. There's a number of recent forecasts for data growth, and I'm sure many of you have seen these that have hundreds of % gains in throughput or in bandwidth use based on video as well as new services that are coming on the market. The working group explored the following key questions. First, what are the providers of fixed and mobile networks doing to monitor this growth? Second, how do they plan to accommodate for both the demand and growth in terms of network architecture impact? And more specifically, what are the operators' plans to provide greater bandwidth, reliability, security, and lower latency to support newer services requiring such capabilities? And how can the use of distributed compute, AI, analytics be used to improve network performance? So in terms of what we're going to cover today, Lynn's going to discuss the convergence of the network access technologies, the integration of compute, storage, and sensing networks. He will cover what is referred to as the emergence of the converged integrated information network, which is a mouthful. And then he'll summarize these topics in several key observations. And to close, I'll present the working group recommendations, the 2019 proposed plans. And just want to call out, there are about 90 slides in this presentation. We are not going to cover all those slides. There's a massive amount of technical information in the addendum that includes a lot of the meetings that were held throughout the year and some of the key findings. So Lynn, over to you.
All right. Thank you. Okay, so again, I want to echo with Russ that both Lisa and Ann are greatly missed as far as here today. And more so, I'm going to say that the rest of us are missing them as far as for their collective knowledge that they would bring as far as to the meeting and asking questions as far as with everyone. So we truly do miss them. So when we go ahead and look at the first blush here as far as what this working group had looked at, it was able to go ahead and see that the advances in the compute, digital storage, and devices are impacting not only the pace of change in the network, but also what you could consider as far as for the middle business model and the new values as far as in the value chains, and then also the pattern of usage as far as across the network. Okay, the accelerating the change in the network can be considered one of the key parts of the development of the national economic competitiveness as far as for our nation, and the digitalization of the technologies will greatly improve manufacturing efficiencies, maintenance, hazard avoidance, operations, and new customer experiences. These will be done through areas such as artificial intelligence, machine learning, AR, VR, cloud, fog, edge computing, and also data sciences. Now, hyper-data growth and reduction in electronic costs continues to drive the value as far as of our networks. David Tendenhouse developed this particular slide, which illustrates the ability to compute that networks computes reside anywhere as far as within the network, and it also gives the user or the provider the balance between the backhaul requirements and the edge compute costs, so it could sit any place or anywhere. For cases with large amount of compute, we're able to have areas as far as where they do require low latency. They can go ahead and move to the device edge as far as compute, and you can go ahead and put a compute status as far as in that particular location and be able to have the network operated as far as there and not go back up the value chain. Compute can be completed anywhere up and down the network as far as for the information flow, and it's a trade-off between centralized and decentralized computing, so you just have to think of the cost and what's associated as far as with that. At the top of the slide, we just show a single cloud, which is a representation as far as of multiple clouds, which these are as far as to be able to do data, deep learning, and to share multiple clouds for public and private networks so that any information can be transferred and be learned upon. Now, breaking the previous slide down as far as into uses, one can see that the network can serve many purposes which are unrelated to the infrastructure that it rides. This allows the network to function as far as for multiple purposes. As an example, in 1996, penetration rates for mobile services were around 16%. Now it's well over 100%, with many of us having multiple devices that we go ahead and use. As an example, the network today can handle IoT as well as fixed wireless, or in fact, in the future, the connected car. The networks have the availability to provide converged access and edge compute. This allows the network to meet new requirements such as jitter, latency, security, privacy, and other reliabilities within the network. Now, this is one of the most important slides that we have as far as from our working group, and it really is to drive the point home that the networks we know today are converging together. Like the antenna technology discussed earlier, as far as the physical and the processing elements working together, we have the same thing as far as with access technologies that are becoming well blended in the sense where the customer doesn't even know what services they're getting from, whether it's a wired, wireless, or cable. They don't know or don't care as far as in the future. And then the converged integrated information portion of the network provides for vertical compute, sensing, and communications at any point throughout the network. As this convergence occurs, the FCC will need to place less importance or less focus on whether their networks are wired or wireless, but will need to look down the road in determining how the policy and regulations will impact the technologies or the technological advantages that are being used. Now, this is a slide from past, I think this was one of NOMI's working groups, but past recommendations of the TAC still hold true. The FCC needs to study to have a deeper understanding of the networks of today, which this will indeed allow us to have the order and the ability to go ahead and track the direction of the converged networks as far as heading for tomorrow. In a sense, what we're saying is that the FCC, if they can get ahead or stay ahead, they'll be able to look around the corner as they're seeing the curve, as far as to look ahead of the curve. Now, to head into our summary section. The working group has heard from 12 external presenters and has had many discussions internally. The group has learned about the current trends and how communications and technologies will affect the network. The working group sees the network can no longer be considered isolated scenes, but must be looked at as an entire picture. The network of today and in the future will require better ways of the management to handle the merging compute and communications. So management of a network is going to become much more important as we move forward. And the working group sees that the network and communication merges may become greater as far as a point to be able to provide economic competitiveness as far as nationally. From this last year, we were able to develop 6 key observations, and I'll just go ahead and cover those. The first observation is growth rates of traffic on the network will continue in a double-digit compounded annual growth for the foreseeable future. So we're thinking that the operators, or we know that the operators will need to go ahead and build and upgrade networks to meet these capacity. And this means that they will have to continue to look at putting money as far as long-term capital investments as far as into their networks. Observation 2, emerging technologies can potentially accelerate the rate of traffic growth and the demand on the network resources. Our working group sees that the advances in the compute as far as throughout the network may reduce or mitigate much of the efforts as far as for the growing technology. An example of this would be security monitoring. If you were able to go ahead and look at all the data locally and just figure out exactly what pieces need to be streamed as far as up the network, then you're going to greatly reduce the amount of traffic that's going to be on the network. The third observation, converged and integrated information networks, which can be defined as the design of the network and its operations tightly integrated with computing, storage, and sensing assets. The trends in network convergence versus the vertical subsets of today indicated that advances will be made in all points of the network from the edge to the cloud. And our fourth item was a converged network through computing and associated technologies will increase the value of the network. And when we think of the value of the network, we think of all the items that are listed there, whether healthcare, law enforcement, manufacturing. But if you look at healthcare, you could see that monitoring in the home or being able to reduce hospital stays, provide early diagnostics as far as for critical conditions would be a great thing to go ahead and have. Manufacturing, as far as when you think of that standpoint, you're also looking at can you go ahead and continue to have manufacturing plants as far as in rural areas versus having to move more toward a city location, or to be able to continue to go ahead and produce products as far as where the actual employees live. Okay, for the fifth observation, and as Marty and Jesse has said, as far as from this, the converged network with integrated services will likely exacerbate the digital divide as we know it today. So we have the geographical divide, which is the rural, sparsely populated areas. And then we also have the economic divide, which is the affordability. These are the points, the 2 points that we really are considering as far as on the divide. Who can afford the service, and do we really have a service as far as in a very rural area? So with this, these 2 divide points will create problems as far as delivering quality of life, business, and public services as far as to all. The adoption of the emerging services are important for economic competitiveness and need to be emphasized across all areas versus just what we consider the populated areas. So the FCC needs to look and consider not only how the services can be used as far as in the urban areas where it can be affordable or financed, also needs to look at what it takes to be able to have rural areas as far as have those same services. So you think of it from an educational standpoint. You want the kids, not only in particular areas, to be able to have access to using these educational services as far as for broadband, as far as in communities that might be a little bit larger, but also in the rural areas. And then, as Marty was saying earlier, as far as having them, as far as in areas that are economically impoverished that need to be able to have broadband brought in for those as well. And the sixth observation is that the FCC and other agencies need to have a traditional, so the FCC and other agencies kind of have a traditional view as far as looking at in silos and working independently as far as across the network. These viewing of converged and integrated informations may require the communications to be looked at as far as in part with greater information structure. So what we're saying is from these groups, the observation needs to be that they converge together to go ahead and look at items and to go ahead and work as far as together to see what an entire network is working on, as far as the FCC in one part, another agency looking at another part as far as for that. So from these 6 groups' observations, I'm going to go ahead and turn it back over to Russ, and he is going to cover the recommendations that we have.
Thank you, Lynn. So Lynn summarized really some of the details in terms of the computational power stress on the network team that they came up with. And as a result, oops, I better hit the next slide. The working groups coined the phrase called digital nation. And that represents both the impending network transformation as well as the societal impact that comes about from that. So getting towards the actual recommendation, the working group encourages the FCC to take a holistic view, as Lynn was saying, instead of these sort of siloed views that have been in the past, of the network related to converged and integrated network information systems. The USA has maintained an economic and technological leadership in communications for well over 100 years. Told you we'd keep it like. Okay, Watson, can you hear me? The working group proposed the FCC to get out in front, supporting and cheerleading the transformation and encouraging the market leaders in communications to drive this change in related technology. Clearly, the communications world is evolving and changing. New services are being added that have stretched or are slightly out of the traditional FCC view and mission. Therefore, we recommend the FCC partner with other agencies and industry to create a digital nation roadmap and plan. This plan should focus on the adoption of a converged and integrated information network, exploring ways to encourage and incent. As part of the plan, the FCC should examine its current policy and regulatory structure to better meet the demands in a much faster technical pace of change on the communications network while maintaining a light touch approach. The second recommendation is related to how the FCC can seize this mission. So the working group feels the FCC should seize the opportunity of transforming communications network more focused on compute, storage, and new services that are changing the landscape. Therefore, there's a need to look at how these changes can be added to the traditional telecommunication or communication focus. This requires an examination of the current FCC structure and if it can be refocused to include these transformations. The TAC recommends the FCC form a study group focused on identifying responsibility changes that are still in the FCC scope, that would allow the inclusion of new technologies, use patterns, and business models. So this is a internal FCC study group that would be formed. And the last slide in terms of recommendation has to do with the divides, and there's been a number of discussions today about the divides. Lynn did a good summary, but CSPN working group identifies that there's multiple divides in the communications world. They include supply of services, geography, economic affordability, and technology divides. Market-driven mechanisms have done a great job in driving new technologies and services that have changed and continue to change the face of communications. The market's also driven large-scale deployments, upgrades, and more. However, market alone does not address all the commercial challenges in all geographies and markets. The TAC recommends that the FCC develop and prioritize policies focused on the challenge of economically viable services in the underserved and rural areas. This is part of what the CSPN calls the digital nation. The key is to place a premium on ubiquity of deployment across America in terms of all services and capabilities. Okay. So how does the FCC do this? I'm switching over to topics for 2019 now. So first, the CSPN working group proposed a 2019 charter plan is to focus on several key technologies that are seen as having a large impact on the communications network. The leading technology capability that is changing network services and support is related to machine learning, deep learning, and artificial intelligence. AI-related technology will provide ability to have automated network management, fault detection, isolation, prediction, and restoration, plus a fresh approach to security. Second, AI will also drive many new services across the verticals, including financial, healthcare markets, education, agriculture, and many more. How will these new services impact the network and the architecture is yet to be seen. Finally, the FCC may also consider utilizing AI-related technology in terms of optimizing regulation and forms of enforcement, as well as other policy topics related to optimization on enforcement. Let's see. Oh, shoot, that's an extra slide. The CSPN will solicit and meet with a number of industry experts during 2019, including leaders in AI, data scientists, deep examination of cloud, data center, and all related to services, and exploring the impact on the communications network. The goal is to provide a clear and concise understanding to the FCC of how AI-related technology will impact the communications network architecture, the mission of the FCC, and potential areas it can be applied to in terms of regulation. So there may even be an AI regulation bot that comes out of at the end of this someday. Oops. Here's just a quick view of a breakdown definition-wise in terms of where artificial intelligence, the different pieces of deep learning, predictive analysis, and so forth fit into that model. We just thought we'd put that up to give an explanation of what we're talking about in terms of AI, deep learning, artificial intelligence, and analytics. Okay. And finally, the world's about to change yet again in a very fundamental way. The possibilities unleashed by information and communication technologies play a key role during driving innovation with broad societal and economical impacts. The FCC has the opportunity and responsibility to plan for and help guide this change to the benefit of the nation and its peoples. And that's it. Thanks.
Great. Thank you, Russ.
Yep.
In absentia, thank you, Lisa. Thank you, Adam. Thank you, Len. So a lot that has been covered in this group. And I'm looking around the table for those that had questions or comments. It appears that we are doing very well with the after-lunch lull. But Walt is here to jump right in.
I just want, I have a question. I just want to make a comment. I had a chance to read the presentation before I left the FCC. There's a huge amount of knowledge and information in view graphs. It gives you a real perspective on future issues, future fundamental changes that we're looking at. I would strongly advise that people look at it. It's very educational.
These are the, you know, if you're not raising your tent card for questions, Russ is fully prepared to cover the rest of the 90 slides.
I do have 60
Just
more
as a-
slides I
as
can
a-
go through.
As a quick comment. Go ahead, Dale.
Mr. Chairman, this may be sort of out of order.
He needs a
but,
mic.
I'm sorry. Sitting here listening to the first presentations, it just occurs to me that there is so much valuable information here, and I'm not sure how easy it is for the general public to find it. I've made the suggestion before, the commission might want to put out a public notice calling attention, and not just to the high-level stuff, but there's been an awful lot of research, interesting stuff contributed by people, outside experts and so forth. And it just seems to me that somehow that information ought to be more broadly conflict of interest. I teach, okay? And this is wonderful teaching material. But anyway, my point is basically, I really do think the tax work has been so good. This round has been so good, we ought to make sure that it is as widely available as possible.
Yeah, which I take to include all of the subject matter experts who presented.
Yes.
It's been one of the highlights
Exactly.
in each of the presentations that have been
Exactly.
provided so far. And these are, using your academic point, many of the presentations that the subject matter experts provided are academic quality. Take it as is and use it for a lecture in a university.
And to identify dissertation topics and things like that as well.
That as well, yeah, great. So,
Yeah, just one quick comment. I know we
Michael's got
brought,
that one. He's going to completely take care of it, where his predecessor didn't quite get there.
In his spare time.
I know we brought this up in the past in a couple of the TAC groups about the FCC website could use a little bit of revamping and maybe some search tools.
Who's on it?
Just-
Really? You have no idea.
Okay. I won't say any more.
Now, for those who are listening in, though it may not be so easy to find, there is if you look for using your favorite search engine, look for the FCC's Technological Advisory Council, or TAC, you can find many of these materials. The comments have been to make it even easier to find, but they are there.
Is that true of the experts' reports, Dennis? That's what.
All the public reports, so everything presented at the TAC.
The briefings to the TAC.
Yeah, that's what I'm, yeah.
No, the briefings are not, no, they've not been.
They have not been. They can be made available. They're in the possession not of the FCC, however, but of the WebEx representatives.
Well, yeah, actually, not as presented, but the PowerPoints in most cases have been made available to the chairs of the working group. So, and one of the questions that is asked is whether these are available for public release, and in most cases they have been. A few cases there have been small pieces not
Yeah,
included.
and so on several of our working groups, we'll go through and we'll have an extensive list of backslides to where we try to collect as much data and notes that we can go ahead and have that would be something for public to be able to look at. It's just that data is not something where somebody would be easily to go look at. They couldn't do a search engine and find it or anything. It's just, it's there, but you'd have to know where you're going to go ahead and look for it.
Precisely my point.
Yep.
Mhm.
Just a suggestion, probably this could be done as a off-cycle task by the chairs, and probably working with Michael in terms of what could be done. I know the information is available. Most of it's been archived on WebEx, which has been a great, thanks for Cisco, has been a great asset in terms of conducting these meetings. And I think it's been standard practice.
Microphones.
Make sure you use
It's been standard practice to ask for releasability of the material, and I think at least in all the participations I've been in, that's been the case. So it's a good suggestion, and maybe it can be looked at.
Great.
We've actually talked about doing this. We've just never had the critical mass to get it done.
Horsepower.
I've been negligent in doing this, but Brian, did you have any questions or comments?
Been following along here at home.
Okay, since this is also a teeing up of your presentation coming in. So actually seeing no tent cards around the table, let's move on to a fresh new face for the 5G and IoT. Yeah, and there's Russ, ably contributed to by Brian, but again, we miss having you here in the room, Brian.
Yeah, Brian, if you need me to, I can cover the whole presentation, or we can try to transition over to you as planned.
Sure, yeah, let's see how it goes, Russell.
Okay. So the first slide, obviously, we've had a couple date slides that misses here that have been scratched out that were unavoidable. You know, I just want to call out my co-chair, Brian. It's been a pleasure working with him this past year, a learning experience, and I think we complemented each other in terms of the focus, in terms of what we brought. Next slide, we have a very, I would say, esteemed group of subject matter experts we're lucky to have on the team. We are going to solicit some additional members for 2018, by the way. In terms of FCC liaisons, we had Walter Johnson, Padma, and Jonathan Campbell. And I wanted to take a moment here to recognize Walter. Obviously, he's retired. But when I first joined TAC, you know, I met Walter and sort of had the interview, and you know, he was, you know, sort of like a coach. And then the second year, he was on my working group again. And then the third year, he was on my working group. And the same, you know, and it seemed, I was like, okay, is he coaching or is he like there to keep an eye on me? And so.
You were on the watch list.
Yeah, I was on the watch list. So I got you something that.
Whoa. This is why we don't throw the remote, by the way.
It's a soft item. I think you, as you transition to your new role, this kind of fits. You could open that up and.
That's clearly very cool.
Yeah, I wrapped it myself.
It says cool on the wrapper for those not able to view.
Apologies for the delay here.
We should apologize for the delivery.
Oh,
I didn't want to hurt
The
him.
reception was a little bit garbled, too.
That's right.
Yeah, it's not from Costco. It's just the bag I had.
Sure, yeah. It was on the sale rack.
No, this is totally
Five
custom.
below. There's one more in here, I'm giving up.
Be careful, there's a small item in the middle.
Okay.
Fragile item?
No.
Oh.
Thank you.
Oh,
Nice.
it even has
Thank you.
FCC logo on
I think you
it?
might have misjudged my size, by the way.
Sorry about that.
But I have a granddaughter that might fit into this.
I wasn't, it is a little stretchy, so,
This is skin tight. This is.
and did you get the whistle to go with it?
Yes, I got the whistle.
Okay.
The whistle
So
will be used.
for the rest of the meeting,
Has to do with Russ talking about, shall we talk about what you were talking about wearing last night?
what was it?
No, I don't think that's.
Oh, no.
Julie would have to step in as an FCC.
Let's get this meeting back on track.
But I think now you can transition from coach to referee of the TAC. All right. So thank you, Walt, for all your guidance. For, I think, a year ago is when we had some rather interesting, heated discussions in one of the working groups. If you remember certification,
Yes.
we had some of those, and then there were some the previous years, some of the policy work. So it's been a fun and exciting time, and it's been great working with you, so you'll be sorely missed.
Thank you.
Okay, back to the presentation here. So let me get into my mode. Shoot. Okay, so in short, our mission is to analyze and report on 5G technology development and impacts, and advise the FCC on ways to incent deployments and remove barriers. That was our shortened mission statement that we started out the year with in 2018. So next, we're going to go through the landscape. Brian, did you want to try to jump in and cover the landscape, or do you want me to continue?
I can jump in and talk a little bit about the landscape. So the slides are actually back a few, so let me just start with slide number 5. and talk about some of the areas of discussion in the fourth quarter. So we looked a lot at the 5G opportunities and challenges, especially the potential barriers to deployment. We looked at, opportunities such as massive IoT, including things such as edge compute and slicing intersection with massive IoT, and what slicing services are and what it means for providers and customers, and how network compute convergence through edge computing comes into play. We talked about policy and spectrum management topics, the new radio and antenna aesthetics, and again, one of the themes that seems to be recurring is the underserved and rural area and how 5G affects the digital divide and education. Move to the next slide, please, Russ. So in some of this framing discussion, we talked, a lot about the standards, what the status of the standards were, and actually there's been some progression, as we'll get into as we move into this year on the standards and progress on the standards and the other areas that we just mentioned. So if we move to this next slide, which has the 5G projected industry standards timelines, this is actually an updated chart than what would have been presented back in November. And the reason for that is there's been some changes and rescheduling of some of the standards activities. And the first thing you note is that 3GPP Release 15 has been split into 3 drops. There was an early release back in December of 2017 to get a jump start on chipset development to support the non-standalone option. There was the mainline drop back in June of 2018, which completed much of the 5G Phase 1 completion, which was the enhanced mobile broadband use case. And then there was a late drop, which was originally scheduled to complete in December, but you'll see those dates have been scratched out, and there's new dates in there. March of 2019, there was actually a plenary meeting last week where the late drop was complete, and then the ASN.1 in June of this year. Now, along with that, Release 16, which contains the second half of 5G standards, or 5G Phase 2 as it's known, that originally was complete in targeted to be complete in December of 2019, but that actually has slipped out to March of 2020. So there was a bit of a delay in that one as well as the standards progress. And the reason for this is there's just so much material going into these releases, so many new features and capabilities. Even with prioritizing the features, it still is challenging to get it done in the original time frame. So we see a bit of a adjustment in those schedules. And as you'll notice on here, there's also 3GPP Release 17, which has, believe it or not, already begun with some study items. And that hasn't officially been scheduled yet, but likely will be sometime, in 2021. Next slide.
Hey, Brian, do you want to hit anything on the 3GPP submission as a candidate to IMT 2020 and the progress there?
Sure. I can talk about that. So as may recall, what kicked off this whole thing called 5G was the IMT 2020 requirements and performance requirements that came out of the ITU. And that process started before 2016, in fact, but the technical performance requirements were finalized in 2017. What this did was set up the requirements that a candidate system must meet in order to be declared an IMT 2020 specification. Those proposals and those candidate technologies to meet those technical performance requirements are on a timeline to be submitted this year, at which point the ITU will then develop the IMT 2020 specifications from those, and you'll see an ongoing IMT 2020 evolution past that. Now, the interesting thing is, in order to meet the full IMT 2020 specifications, it requires 3GPP Release 16. And as I just mentioned a moment ago, 3GPP Release 16 has had a slight adjustment into early 2020 for completion. So there's a bit of a mismatch there, and that's actually going to be subject of a discussion at the upcoming 3GPP PCGOP meeting, program committee meeting, to decide how they're going to handle that and how that's going to work, getting the 3GPP specifications into the ITU on time. Okay, next slide. We also talked a lot about deployment, and I'm sure everybody has seen the news articles on different deployment announcements that have come about since the end of last year. We've seen 5G commercially available starting late last year, and much more coming on board this year. Initially, these are non-standalone, but with some standalone for fixed wireless access. And some operators have mentioned that 5G, at least initially, is largely an enterprise play. And this is not just unique to the U.S. There's trials, proof of concepts, and real deployments underway, both here in the U.S. as well as worldwide. Next slide. So some of the barriers to deployment are when we get into small cells and millimeter wave, we certainly have densification. And in order to get the approvals and negotiate with the cities, landlords, and so forth, it could take up to a 2-year cycle in order to do the small cell densification and deployments of the small cells that are going to be required. Not only that, but you need to ensure that you have appropriate backhaul and power. And as mentioned earlier in the antenna working group report, there's a lot of focus on aesthetics and environmental regulations that need to be accounted for as these small cells and as we densify the cells. Transport, obviously, is another big issue, both backhaul, front haul, and cross haul, as well as location. The real estate owners and property managers need to understand what they can do to ensure that their buildings are small cell ready. So, the whole small cell and densification is really one of the major issues and also the major potential barriers to deployment of 5G. Next slide. From the network slicing perspective, early forms began actually in LTE, but were never really fully realized in 4G. What network slicing does is it enables network elements and functions to be easily configured and reused in each slice to meet specific needs. It's conceived to be an end-to-end feature, not only a network service, but also includes the radio access network, and it has its own network architecture and network provisioning. The slice itself comprises dedicated or shared resources, which can include processing power, storage, bandwidth, and has isolation from other network slices, and can also span across multiple network parts, the terminal, the access, the core, and the transport, and potentially even across multiple operators. For example, the GSM Association is looking at defining roaming specifications for network slicing. So how do you support slices that span across operators? And of course, there's IoT support, where you might have options on quality of service, latency, and so forth that might be supported in a slice in order to support a group of IoT devices. Next slide. Edge computing, the basic premise for edge computing is you want to put a lot of the smarts as close to the edge as possible. And this really extends the cloud from a centralized single resource to a local environment. One of the main reasons you want to do this is to lower the latency. If you have a application that requires you to get as low latency as possible, one of the ways to do that is to push all the resources close to the edge as possible, so you minimize the network latency that's going to be required for that particular application. This is important, for example, like automated driving, traffic control V2X services, AR, VR, mission-critical services, remote healthcare, extreme real-time applications, and HD video sharing, industrial and manufacturing applications, and the enterprise applications. Next slide. Again, the antenna aesthetics is one of the areas that have a lot of focus within the TAC this year, both within our working group as well as the antenna working group. The intent is to reduce barriers to the new radio acceptance. The densification of 5G millimeter wave requires a greater number of antennas than we traditionally would see in a cellular system in the existing spectrum. So we need guidelines for technologists for antenna design and placement to meet varied zoning requirements of municipalities as well as enterprises, as well as address both brownfield as well as new greenfield deployments. Next slide. And the digital divide offers both opportunities and challenges. And the rural versus urban issue is one we discussed quite a bit. Without 5G wireless broadband in rural areas, they're going to run the risk of falling behind the urban areas. LTE is not going away anytime soon. It's continuing to evolve speed and latency, and expect deployed LTE speeds to be less than urban areas, however. And we're seeing 100 megabits per second up to gigabit speeds in urban areas. The millimeter wave bands will have benefit in urban and suburban areas, but they're going to be very localized, and inner site distances will reduce across the board when provisioning broadband services. It's important to remember, though, that the 5G new radio technology is not restricted to millimeter wave. I've seen a lot that focus on the millimeter wave aspects of 5G, but it can also be deployed in the low cellular bands, which may bring benefit to the rural areas. And the rural communities benefit as transport infrastructure is built with mid-band and millimeter wave band. Some deployments are likely to be capital intensive, which are challenging economics. The wider bandwidths than 4G are anticipated at mid and millimeter wave. The lower bands and millimeter wave are likely developed in parallel. Carriers are not choosing one over the other. We've seen announcements where carriers are deploying both. And the difference is in timing and how carriers will manage the spectrum in the sub-6 band. So I'll turn it back to you, Russ, for the recommendations and supporting documents.
Thank you, Brian. Hope you're feeling better. Okay, so let's start to talk about the recommendations and some of the supporting documentation that the group produced over the year. So the team produced 2 informative papers, one on 5G slicing and one on mobile edge compute. We also came up with a recommendation as well as an advisement related to slicing. We have a recommendation and an advisement related to rural and underserved, and a recommendation on the antenna new radio siting as well. So let's take a look at some of the details here. Here's the covers of the 2 white papers. I'm not sure how these will be shared, but these will be great to get posted up on the FCC website for public sharing as well.
Yes, they will be. Yes.
Okay. And then for slicing, this is our both recommendation and advisement. So first, the FCC TAC working group suggests regulatory certainty in terms of slicing service offers. Example, what are the do's and don'ts? Are there any foreseeable constraints based on existing or potential rules in terms of offering slicing services, or should it just be assumed that slicing falls under the moniker of special services? Number 2 on that, does the FCC have a viewpoint related to slicing for emergency or critical services, such as public safety related services? Slicing may provide an opportunity to bring emergency services more into the core infrastructure. And the FCC, our viewpoint is the FCC should stay current and alert for any potential market disparities as 5G evolves. We're not calling out anything at this point in time. It's too early, but there is a possibility for some disparities, at least in our view, and we want to keep an eye on that. And Also to be attentive to the market driving slicing interconnects between characters. There may be a role the FCC can play to establish some type of a slice exchange, like an interconnect capability. Right now, it's being determined most likely by business models themselves. On 5G antenna aesthetics, so the working group agrees with the antenna group in terms of creating a public notice to gather cross-industry stakeholders, such as providers, industry vendors, system integrators, citizens, and cities, and agree on a set of guidelines as an output in terms of how to get antennas built. I think we're at the very early stages of this in terms of deployment, and we're probably going to start to see some problems as deployments go on, especially as Brian pointed out, millimeter wave is going to require 10, 20, 30 times the number of antennas that are there today. Okay. And by the way, we feel the FCC has a great influence in the cellular industry as well as the market in general, so they can do a good job on that public notice. On underserved and rural communities related to 5G, so we spent time on and off throughout the year on this, and I have to say, rural and underserved coverage is always one of the most difficult challenges, and I think the TAC's looked at this every year that I can remember. And we've tried to slice it every way you can slice it, no pun intended, on 5G. But looking at how can we really incentivize deployments that are ubiquitous and provide broadband to all Americans. So the TAC's view is the economics alone can be challenging. However, there are clear anchor opportunities that could be leveraged to drive funding and deployment, areas like health, education, agriculture, transportation. We've talked to a number of these organizations and subject matter experts looking at what could be anchor tenants or what technologies, whether it's smart farming, education, remote healthcare. Marty's provided a good framework as well and is continuing to work on solutions that we can propose. So the recommendation is for the FCC to initiate an economic model for service ubiquity, expanding on the anchor opportunities. And this would help probably identify where more work needs to be done or funding needs to be secured. The advisement is, at least at this point in time, the TAC would like the FCC to focus on the potential widening of the digital divide. As I think it was pointed out earlier by Marty, it's becoming a chasm. As 5G is deployed between urban and rural versus underserved, the FCC should explore ways to encourage and or incent developments across all geographies. And next, we're going to talk a little bit about the proposed calendar year 2019 activities. So there's a slight change to the mission where we're going to spend more time focusing on some of the applications, the specific verticals, just like 3GPP, Release 16 and 17 are looking at some of the vertical specific applications. We want to stay ahead of the curve and make sure that we're looking at what that impact to the network is. We do plan to work with the computational power stress on the network group as well throughout 2019 to explore some of those areas. We also want to explore current rules, regulations, specifically as they relate to 5G. We talked a little bit about slicing services, take a deeper dive on rural and underserved impacts and how to incent those again. And as we evaluate these initial deployments in 5G, identify any of the barriers or opportunities or best practices that could accelerate the deployment in the United States. And some of the focus for priorities, I may be a slide or two behind here, I apologize. Track 5G status in the US and worldwide and provide updates to the FCC. Keep the FCC up to date on standards progression and related to Release 16, Release 17, ITU. Release 17, as Brian said, will probably be firmed up in the next month or so, and how this could impact the network and or policy related to the communications network. Also examine worldwide spectrum. It was one of the initial tasks we're going to look at and explore opportunities such as light touch licensing and non-public spectrum. And work group priorities. I think I hit most of these in terms of slicing, rural, The one we did not talk too much about that we will be looking into is 5G security and trust, including malicious IoT attacks. Obviously, 5G promises massive IoT, along with massive broadband. Massive is a big word in 5G. But we want to look at the impact of potential DDoS attacks, physical layer attacks as well, illegal transmitters, jamming, spoofing, and also explore what is being provided in terms of standards bodies related to security. Okay, so additional topics that we call sort of get smart about it or stay up to date on. Whoops, one too far. Are mobile edge compute standards, industry use of open is one of the topics. There's some efforts going on in terms of Open RAN, which could help drive the market even stronger. We also want to look at the impact on the different verticals and how things like ultra reliable low latency communications replies to that. And then look at some of the new players and new opportunities from SDN, Edge, Virtual RAN, SD-WAN, Open RAN, et cetera. Also identity management, SIM evolution, and privacy. So we have a lot on our plate for 2019 on the proposed plate. As part of that, I would like to, we're going to meet with a number of organizations that you can read here, but we would like to recruit a few other members to our team. We are lacking in terms of over-the-top players or cloud players. So Paul, Milo, Hamid from Samsung on the equipment side, as well as Kerry on the T-Mobile side, we could use your support. So my official request of recruiting is out to each of you and anybody else who would like to participate and contribute. Thank you.
Not to name any names.
Not naming names, yes. Questions?
Yeah, Russ, sorry. Nice job.
Before we get to questions, we do have our business matter of approving, since the reports do come out as TAC reports. Our process is, in fact, to one of the rare times when we actually vote. But we'll take this as in the normal structure of things as a committee recommendation, so it doesn't need a motion or a second, but it does need a vote. So hopefully most of you have had an opportunity to review the papers. They're really quite well done, even with color on the front. So any questions or comments about the two white papers before we take a vote to approve those as TAC level white papers?
Yeah, I'd just like to make one comment. I want to thank our white paper editor, John Barnhill, who made those very pretty and put all that content together and made it look nice, as well as contributed technically.
In that order of... Okay, any other comments? All in favor of approving both the slicing and the edge computing white papers as TAC level white papers, say aye. Aye. All opposed, same sign. We'll take that as unanimous approval, and those are therefore TAC level, even though created by one of our working groups. They are now TAC level white papers. So thank you for that. And now we'll move into the more general questions and comments. And
Yep.
Shahid,
Yep,
please.
no, nice job again, Russ, well done. So, for the future tech scope of work, I would suggest maybe looking at specific 5G use cases and applications. I think you touched upon that a little bit. Just from my survey of looking at different enterprises and other large companies, they're all viewing 5G as pretty disruptive for their own business models and the business outcomes they're trying to achieve as a result of this new technology. So it'd be good to survey what are those specific use cases, and perhaps even just educate the wider, broader group what they are. We've all talked about AR, VR, and some of the other data-intensive 5G use cases, but there are other
use cases a lot of companies are contemplating. So I just wanted to make that comment.
Thank you for the input. We'll definitely do that. I will say, initially when we started the working group, we did look for sort of the killer app for 5G, and we were unable to identify the quote killer app. I think, you know, the exciting part, and I think everybody in this room should be excited about 5G because of all the great capabilities it brings in terms of, you know, there's a lot of negative press out there too, but I think when you look at slicing, when you look at the massive broadband, the low latency and so forth, we're going to see services that pop up because we're talking about 10x and more increase in some of these or decrease in terms of latency. So we're going to see services that we don't even know exist today that are going to take advantage of this, which are pretty exciting. So, but we will take a deeper look, like you said.
Russ, on your recommendation on B in the critical services and public safety support, I think you could tie that in with the way you're talking about interconnecting, getting more into a lower layer from cloud to fog. The public safety in each one of the locations through the DHS rules all have secure facilities. They all have battery backup generation guarded just like a typical data center, but they're in each governmental authority organization, so they'd make an ideal location for peering in between the carriers or between each of the providers in each location. And at the same point, it would provide more redundancy for the public safety and emergency services communications in each one. If you were to look at basically possibly requiring broadband providers to peer at the PSAPs, that would be a very cost-effective, safe place, carrier-neutral type of operation. So I don't know if you thought about it or not, but yeah. Okay.
We'll add that to the list, and we're glad you're on the team.
Okay.
Yes, I've heard the discussion of potential low latency applications many times. When I was in Barcelona, I heard a talk by a professor from TU Dresden who actually tried to implement it, and he found that the constraint was not in the 5G communication system, but in the virtualization layer in the edge computing. That's where all the latency went that broke the 1 millisecond end-to-end model that he was trying to achieve. So I would just encourage you, if you're looking at the low latency application in 2019, to include the virtualization component in that as an essential part of the end-to-end solution.
That's a good point. I think what we'd like to find maybe is where the weak links are.
Great.
I just want to amplify something Shahid just said, and my experience, because I'm a bridge between the TAC and other elements of the FCC and other groups, is that is that you lose people not entrenched in the technology. When you talk about low latency applications or virtualization or slices, the more you can bring the vision into this application or this scenario, the broader the audience you're going to reach. And I would advise both the TAC and possibly with outreach to 3GPP to try to reduce the technology to applications that matter to people so that they can talk to people in a way that people will understand the potential of what's being talked about. I don't think they understand today. In some instances they do. 5G, for example, is thought to be a way to watch movies with the high bandwidth wirelessly. Okay, that's just one, as Brian keeps pointing out, one very small application that's a possibility. But if you're going to get the support of the people, you have to meet them at different levels, and one level is explaining what this is going to mean to their daily lives. We're a long way from being able to do that.
That's a good point.
Michael.
So maybe this is for Brian. You know, looking at your chart on slide 7 that talks about the timeline for IMT 2020 with the 3GPP timeline. You know, I don't want to use this horse analysis, but you know, how many horses are actually racing for this 5G technology? Is that just a 3GPP? I'm assuming there's some sort of IEEE standards might be competing in this space, but are we looking at just like what we have today, 4G LTE plus a variation of 802.11 technology? Is that what the carrier's going to be compete in the market space?
Well, I think when you look at the IMT 2020 proposals and the technologies that are being developed to meet the requirements, Certainly, the 3GPP standard from a commercial mobile standpoint is really the only one that's out there. Certainly, a complement to that is the IEEE technology and the evolution of the 802.11. But I wouldn't look at that as necessarily competing. I'd look at it as complementary because the 5G 3GPP system is being built to support non-3GPP access, which would include 802.11 and its evolution.
Gotcha. So I'd like to make a suggestion that maybe one of the future topics is maybe looking into how would carriers actually differentiate themselves, although they are based on the same type of equipment, technologies, devices, but maybe there's some service aspects that may be more attractive to one from others besides the pricing that we're all competing today. Maybe there's something that we can have a bit of appreciation of what these new technologies can offer to different people.
That sounds good.
Thanks, Brian and Russ. And maybe this might be a little bit of a build on Mark's comments or even Shahed's as a use case. But I guess when Dennis talks about how we're here, to do something for our country and our government. One topic that always is on my mind in a lot of these working groups, and I think I learned about it first maybe 3 or 4 years ago when we studied quality of service on various types of networks. And I learned how almost every type of network has similar characteristics to be able to handle quality of service. And to me, I've always felt like emergency services is such a perfect use case for better using the intelligence of our networks. When we think about our roads, we didn't design emergency, we don't segregate off special sections of our roads for emergency use services, but we allocate priority on our roads to all roads when we need it. And I still feel embarrassed at how our country handles emergency services on networks. I'm sorry to say it. I love the work that FirstNet did, but I don't like the design of it as a technologist. I think they worked hard, but I'm embarrassed as a technologist for we could do better. So to me, 5G, I wonder, and I saw this in one of your slides about, in the network slicing slide, there was a reference to it, but I just wonder, could we better design fundamentally emergency services into 5G better? And I just think this could be a great recommendation from the TAC to the FCC about how to better design how our country handles emergency services using every type of network there is. We have such rich networks throughout our country. Why doesn't our satellite network provide some emergency services? Or we all should have an obligation. So anyway.
Good.
Mm-hmm.
Yeah, just one, and Walter and I had talked about this, I think, at the start, but I'll bring it up anyway. Let me see if I can get this a little closer. Thank you. So, I think it was a couple of years ago, GAO did a study, and one of the things they came back to the commission with was that the FCC should monitor the high bandwidth IoT applications and how they might impact network congestion. And I think we struggled with this a little bit because, how do you actually monitor video or how do you identify what's high bandwidth versus not? And so one of the things we were, I think, going into this hoping for was maybe somebody else had an answer. So I don't know if in the next round we try to think about that a little bit and how I'd also say it just kind of goes hand in hand with, I like to think here we're comfortable with the unknown. That the policies that are set up are designed to facilitate people to innovate and invest. And so when people come to us and tell us and say to us, Well, tell me what it's going to be like in 3 or 5 years. And I joke, I don't know what it's going to be like the next 2 months. and it's good to try to look ahead in this. But one of the struggles here, I think, with IoT and it's not only 5G. It's obviously 5G isn't the only place that IoT has been deployed. It's actually been around, as most of us know, for a long time. Is trying to. I think what people look at is, well, why didn't you know this was coming? and why didn't the carriers anticipate it? And the carriers often are out there trying to build as much capacity as they can to be ready for it. So how that weaves into looking down the road, 5G and IoT, maybe is something to think about a little bit more. I don't know that there are answers out there, to say, here's what, we can sit here today, we talk about AR and VR and transportation and all these great possibilities. But there were a lot of things that happened in the last 10 years that nobody knew was coming. and that's probably a good thing.
I think it's a good point. Just taking a look at connected vehicles, notice I didn't call them autonomous, but connected vehicles truly rely on network connections and can generate massive amounts of data. And so I think this is going to be an interesting development. What we've seen so far, though, for instance, on some of the IoT, just because 5G doesn't exist with some of these massive bandwidth capabilities, is this push towards fog compute, edge compute. I think Adam's team, CPSN, looked at this in detail as well, and we look at trying to figure out where we divide between the two working groups on exploring that. But obviously, you look at some of the new machine learning video cameras that are out there, a lot of the machine learning is embedded into the camera now. So part of it is, it's kind of like the CDN network evolved to support, because you can't send everything down long tail from the cloud, right, in terms of video. Right. So I think there'll be some novel solutions, and this is where mobile edge compute and capabilities like that come into play, or just more pervasive intelligence embedded onto devices.
Good. Brian.
Yeah, and this may be a follow-on to Julie's comment about the flexibility to innovate. This is mostly my lack of understanding of how the relationship between spectrum and required services. So let's say a carrier has over time now accumulated low, mid, high band, and we're moving to this world where everything's flexible. So does every band have to support like voice services? I mean, I could see where it may be much more efficient to slice low band across a bunch of simple IoT services, for example, and not do voice and not do a lot of other things that we traditionally thought, well, you must do. None of the users can tell because in that geographic area they got the service, it's just in a different band. Or do the rules allow all that, all the foreseeable flexibility of the slicing we just saw described?
Yeah.
Do they? Okay. It's not
It's all just data now.
Okay.
Yeah, and I'd actually turn that around and say, you look at the millimeter wave where you have large bandwidths, i.e. can get higher speeds. You don't need that for voice, right? So that's really, the higher bandwidths and millimeter wave frequencies are really tailored toward more the enhanced mobile broadband use cases where you're going to need those higher speeds.
Yep. Great. Good point. Thank you very much. Russ, thank you for the double duty. So appreciate that. But appreciate the 5G IoT team. A lot of meat there, and still a lot. Even though it's in the news every day, there's still a lot underneath the surface that is not widely known. So expertise that this room possesses and the SMEs that we're able to pull in and really add a lot of benefit to understanding. And with that, we turn to Melanie, who is the cleanup hitter role, and also serves as the chair of the longest lived working group that is currently in existence. So, Melanie, please take it away.
Yes, thank you. And the last time I was the last presenter, it was on me to speed things up to get us out of here on time. But given that the celebratory essentials do not arrive until around 2:30, I'm going to take this as my obligation to slow things down a little. I was not prepared for the speediness of some of our afternoon working groups. So thank you again. I'm happy to be here to sort of provide, not sort of, to actually provide the overview of what the Mobile Device Theft Prevention Working Group worked on throughout the past year. As you said, this is sort of the longest standing working group of the TAC. I've only been a part of it for the last year, but I think they've done a lot of great work. So if we could have the slides, we can move through what we've worked on this year.
And for Brian on the phone, it seems like only yesterday you started this, right, Brian?
Sure not, yeah.
No comment.
Exactly.
No
So thank you again to all of the participants that worked on the working group along with me this year. I know some of them have been here for the entire process, and so their expertise has been incredibly valuable, and thanks to Walter, you will be missed should this working group continue again into the next TAC. But there was a lot of good work and effort from our participants. So as always, given that this is the longest running TAC working group, I like to start with a little bit of history and a little overview of what all that has been accomplished by the group. So since its inception, the working group has made significant strides towards creating solutions to help deter the criminal theft of mobile devices. These solutions include coordinating a voluntary industry-led effort to implement recommendations for consumer anti-theft features and tools on devices, and also the development of the Stolen Phone Checker, which enables consumers, commercial entities, and law enforcement to verify whether a device has been reported lost or stolen. A key part of the initial work of the working group was to develop recommendations for visible opt-out anti-theft features to be embedded within mobile devices for consumer use. Working group members responded by coordinating a vigorous and dynamic voluntary industry-led effort among the manufacturers to implement these recommendations. In an April 2012 voluntary commitment, industry participants took steps to deter theft, and in the smartphone anti-theft voluntary commitment of 2014, participants agreed to provide remote capabilities to wipe information from new smartphones, among other security measures. So the smartphone anti-theft voluntary commitment provides that new models of smartphones first manufactured after July 2015 for retail sale in the U.S. will offer at no cost to consumers a baseline anti-theft tool that's preloaded or downloadable onto wireless smartphones and provides the connected capability to remotely wipe the authorized user's data from their smartphone in the event that it's lost or stolen, to render the smartphone inoperable to an unauthorized user, for example, through locking the smartphone so it can't be used without a password or PIN, to prevent reactivation of without the authorized user's permission, including any unauthorized factory reset attempts to the extent technologically feasible, and importantly, to reverse the inoperability if the smartphone is recovered. Oh. Huh. Moving it for me. The Stolen Phone Checker is the other effort that I mentioned that has been a huge success and a big accomplishment of the working group. So based on the efforts and recommendations of the working group, CTIA launched the Stolen Phone Checker in May of 2017. The Stolen Phone Checker is a tool which is powered by the GSMA Device Check Service, and it's a public service designed to limit the resale of lost and stolen mobile devices in the U.S. and to help consumers, businesses, and law enforcement agencies to learn the status of a device and ultimately make informed choices. When launched, the service garnered significant media coverage, and this coverage continues today. And as of yesterday, more than 1.7 million queries have been made to the database. So the working group has reviewed the effectiveness of these and other efforts to raise awareness and increase the use of tools to protect against and recover from mobile device theft. Consumer education appears to have had a substantial impact on the practices of consumers and has helped to ameliorate this public safety and consumer protection challenge. In the report that we shared with the working group, we do have a section on all of the efforts throughout industry, the FCC, and others to help to educate consumers and law enforcement and everyone about the tools that are available, and also the presence of the stolen phone checker. A recent Harris poll that commissioned by CTIA to survey consumer awareness and adoption of cybersecurity features and tools shows that America's wireless consumers continue to adopt anti-theft features and more advanced security measures for their mobile devices amid ongoing consumer protection and education efforts. Nearly 60% of American smartphone owners reported being aware that they have the Find Your iPhone or Find Your Phone capability on their device, allowing them to remotely locate, lock, and erase their smartphones if they are lost or stolen. The working group attempted to determine the effect of these efforts on the number of consumers impacted by mobile device theft. So using the Harris Poll survey results and publicly available data on the U.S. population, the working group was able to derive that between 2016 and 2018, the number of consumers impacted by mobile device theft has dropped dramatically. Our estimate suggests that theft of mobile devices has declined by more than 50%, which is consistent with anecdotal press reports from key U.S. cities that I've cited a few times in presentations. And so the chart up here sort of illustrates the decline. While the timing appears to align with the introduction of the various anti-theft tools that I've described and the stolen phone checker, further study would be required to determine the exact correlation. So for 2018, the working group was asked to build on earlier work and attempt to identify statistics that help support anecdotal evidence suggesting a decline in device theft, and also to focus on international engagement to determine where the stolen devices ultimately end up. Specifically, the chairman tasked the working group to focus on supporting FCC efforts and working with foreign regulatory agencies to combat the theft and use of illegal mobile devices, including working to identify where devices go once stolen, to reassess the effectiveness of the information portal or the stolen phone checker and make recommendations as appropriate for its future improvement, to study whether mobile device theft has declined in the U.S. since these efforts have been implemented. So with this tasking, the working group focused on three primary areas. We focused on continuing to work with law enforcement to assess the benefits of the information portal to relevant stakeholders and identify potential enhancements, to develop baseline statistics on device theft based on the data from directed consumer surveys and law enforcement to help track long-term progress and identify theft scenarios, and to study future mobile device thefts and trafficking across international borders and to make further recommendations. So on the first tasking, continuing to work with law enforcement to assess the benefits and identify enhancements, the Stolen Phone Checker tool was created to assist with combating mobile device theft. Over the past year, the working group explored what improvements could be made to the database to make it an even more useful tool, both for consumers, commercial users, but specifically for law enforcement. Two possibilities arose during those discussions: to develop the ability to use the Stolen Phone Checker as a tool to help mitigate the problem of contraband phones in prisons, and to find ways to streamline the onboarding process, making it easier for individual law enforcement agencies and officers to take advantage of the tool. On the contraband issue, there is a separate task force outside of the TAC that's dedicated to working on this issue. They've made significant progress and are continuing to work on how best to use the Stolen Phone Checker and the GSMA blacklist to assist their efforts. One of the discussions is whether creating a specific contraband reason code in the Stolen Phone Checker would be useful, and that's a discussion that is continuing to go on. On efforts to streamline the onboarding process. So as this group is well aware, there are approximately 18,000 different law enforcement agencies throughout the U.S. at the federal, state, and local levels. Each of these agencies has their own processes for approving contracts and managing their own investigative procedures. Several agencies have reported challenges with the process necessary to be onboarded to use the Stolen Phone Checker. That said, possible solutions are continuing to be explored. GSMA is continuing to look at how best to ease the onboarding process to make it easier for law enforcement officers to utilize the Stolen Phone Checker. On efforts to increase the awareness, we also identified a need to continue to work to enhance the awareness of the tool broadly, but specifically throughout the law enforcement community. Currently, there are 56 law enforcement agencies signed up to use the Stolen Phone Checker. They range from large police forces, such as the NYPD, to smaller ones throughout the U.S. Since the inception of the Stolen Phone Checker last year, the industry has worked to increase awareness. In particular, CTIA has worked to share information related to the Stolen Phone Checker, including capabilities and how to sign up through op-eds, written collateral circulated among law enforcement agencies. We discussed it with, especially in the immediate area, with the DC police and the state police offices in both Maryland and Virginia. In addition to these efforts, the law enforcement community is also working to help raise awareness. In November, the International Association of Chiefs of Police, IACP, adopted a resolution to further encourage mobile network operators worldwide to participate in the global GSMA IMEI blacklist database. So for our recommendations for this first issue that we attempted to address, since its launch in May of 2017, the Stolen Phone Checker has been increasingly adopted by consumers, commercial resellers, and law enforcement. While this is a successful and promising start, the working group recommends the following to continue to enhance this initial success. We recommend that CTIA and GSMA continue to monitor the Stolen Phone Checker to identify possible enhancements and make any necessary changes to increase the effectiveness and encourage broader adoption, including efforts to streamline law enforcement access and enrollment in the Stolen Phone Checker service. And we recommend that the FCC should continue to promote the Stolen Phone Checker to consumers, retailers, and traders of devices and throughout the law enforcement community, possibly through engagement with local law enforcement agencies and with law enforcement associations, such as the International Association of Chiefs of Police. So the next area that we looked at was how to develop baseline statistics on device theft based on survey data and law enforcement to help track long-term progress. So for this, we focused on two primary sources of data to develop baseline statistics: consumer surveys and law enforcement data. So I'll start with the consumer surveys. CTIA annually commissions a Harris Poll to conduct surveys with respect to consumer awareness and adoption of security measures, including the adoption of anti-theft security tools on smartphones. This year was the fifth such survey conducted since 2012. An online survey was conducted in May of 2018, focused on U.S. adults who own and use a personal smartphone, tablet, or both. The survey confirmed that consumers continue to adopt strong cybersecurity practices to protect their mobile devices and their personal information. The survey found that almost 3/4 of wireless consumers reported using PINs and passwords on their smartphones, which is up significantly from the first survey conducted in 2012, where only 50% of users reported using these features. 57% were aware of having built-in remote lock and erase software installed on their smartphones. Nearly 3/4 of consumers run software updates every or almost every time on their personal smartphones. Almost half of users responded having an antivirus program installed on their smartphones, which is up 18% from 2015 and up 52% from 2012. And 90% of respondents say they're familiar with the term cybersecurity, defining it as protection, safety, and prevention of unauthorized access. So the survey also found that only 9% of respondents reported losing a smartphone. This is down from 13% last year. Of those consumers who reported having lost a device, only 20% reported that the device was actually stolen, with the rest reporting that it was simply misplaced. The percentage of devices being reported as stolen as opposed to misplaced has decreased year over year, and the charts up on the slide illustrate that. As previously noted, 57% of smartphone owners say they are aware of having built-in capabilities for remote lock, locate, and erase. Of those respondents who are aware of the capabilities, nearly 70% acknowledged having enabled it. More than 40% of those not enabling the anti-theft capabilities cite a lack of need, not having enough time to enable, and concern that they might accidentally lock or erase their data are among the top reasons for not enabling it. And notably, and I think I shared this statistic before, 34% of consumers not enabling the capabilities said that losing their phone would actually encourage them to enable the features. The working group attempted to collect data from law enforcement agencies, but as the FCC knows, there are challenges to collecting meaningful, comparable law enforcement data. Data about the motive for thefts, the property stolen in a robbery, or the use of anti-theft tools by victims are hard to obtain because they're not routinely collected by law enforcement around the country. More generally, what we found is that law enforcement agencies often have different obligations when it comes to collecting data under varied local, federal, and state laws. And those that do collect data specifically on mobile device thefts don't always collect and categorize that data in the same way, making it difficult to compare. Given these challenges, the working group turned to publicly available data to try and fulfill some of the other questions that we had. What we were able to find showed that since 2013, reports of mobile device thefts have shown indications of steady decline. In Washington, D.C., Metro Transit Police data showed a decline of 51% on the theft of cell phones from 2013 to 2015. And the New York City Police Department's crime complaint database includes details about crimes related to electronic devices. According to this data, thefts of personal electronic devices in New York have fallen by a third since 2013. Another survey from 2015 found that smartphone thefts dropped as phone manufacturers and carriers enabled deactivation mechanisms, which make lost or stolen phones unusable. So despite our efforts to identify sources of law enforcement data that could be used to refresh and validate this data, we face challenges, and therefore we don't have complete information related to mobile device theft nationwide. As a result, the working group recommends that stakeholders, including the FCC and industry, continue to focus attention on building enduring relationships with groups that have broad memberships, such as the IACP, Major Cities Chiefs of Police Association, the National Sheriff's Association, and others, to help simplify the efforts of gathering mobile device theft statistics. CTIA's Stolen Phones Working Group is also a possible point of contact outside of the TAC Mobile Device Theft Prevention Working Group. And we also recommend that the FCC consider additional methods to gather statistics related to mobile device theft. For example, the FCC could work with the IACP or other associations to conduct a survey of their members. And finally, industry groups are encouraged to continue to conduct surveys to identify consumer trends, awareness, and adoption of available security and anti-theft tools. Future surveys could expand upon the source of consumer knowledge and awareness, such as are consumers implementing these practices based on carrier recommendations, law enforcement, public awareness campaigns, or news sources. Determining where most consumers are obtaining information about mobile device theft practices may help to sharpen the focus of existing messaging, identify potential gaps in information, and enhance the most effective means of reaching end users. So for the last area that we focused on this year, future mobile device thefts and trafficking across international borders, the working group was asked to engage with international counterparts and examine how mobile device theft prevention is being addressed internationally. In addition to exploring the differing approaches to device theft mitigation, the working group was tasked with exploring whether information could be obtained to help answer the question of where stolen devices end up, a question which has proven challenging to answer. So we initially focused on the Latin American region, specifically Colombia, Brazil, Peru, and Costa Rica. So this region was selected in part because of the focus on mobile device theft throughout the region and many efforts already underway. In Latin America, two primary means for mitigating mobile device theft have emerged: IMEI-based blocking measures and technical solutions. For blocking measures, there are lists for both blocked devices, blacklists, and permitted devices, whitelists. Within Latin America, subscriptions to the GSMA's database rose rapidly after a 2011 resolution by the Inter-American Telecommunications Commission, promoting measures to fight device theft. So the CTEL is comprised of governmental representatives and associate members from industry. Latin America has so far focused primarily on a combination of blacklisting and whitelisting to attempt to curb mobile device theft, with little effort to promote technical solutions. So as we discussed earlier, manufacturer-led technical approaches to deter and prevent theft, such as kill switches and CTIA smartphone anti-theft voluntary commitment appear to make significant impact on the rate of device theft. These solutions are generally available to smartphone users worldwide, either directly from manufacturers or through the internet as downloadable applications. However, while these solutions have been publicized widely throughout the United States, there's been little high-profile support or consumer education efforts for such technical solutions throughout Latin America. As a result, consumer adoption of such technical solutions seems to be lacking throughout the region. So as part of our efforts, we joined the FCC in conducting interviews with each of the four countries that I mentioned before. The chart illustrates each of the countries' response to whether the country uses a blacklist, a whitelist. As you can see, each of the countries uses the blacklist, and 3 out of the 4 currently use a whitelist approach, while 1 is still in testing modes. Each of the countries also discussed challenges that they faced. All of the countries highlighted challenges with IMEI security among their primary issues, as this decreases the effectiveness of blacklisting capabilities, which is the primary method that they rely on. IMEI integrity is an issue that this working group has explored in the past and was documented in past reports. For reasons not quite clear, interviews conducted by the working group suggest that IMEI security is not a significant problem within the United States, despite being reported throughout the Latin American countries as their primary concern. As we've discussed previously, tracing the movement of devices once they're stolen can be a challenge. It was reported in an earlier report produced by the working group that the relationship between mobile phone subscribers and operators make this difficult to track. The working group attempted to obtain information during our conversations with other countries that would assist in identifying where the devices stolen in the United States go. While most of the countries expressed an interest in attempting to locate and share data on this point, as of today, the working group has not obtained any additional information. So as a result of these interviews and other work completed by the working group, we have a few recommendations. So we encourage the FCC staff to request and review evidence from international counterparts to assess the differences internationally, including the prevalence of substandard and counterfeit devices in local markets that may make IMEI duplication a problem abroad, but not a problem domestically. Continue to engage with our South American counterparts on mobile device theft issues relating to collaboration on the global blacklist database, country-specific concerns such as duplicate IMEIs, and issues related to whitelisting, international trafficking of stolen devices, and sharing of best practices. Continue to promote and expand awareness and use of the GSMA blacklist. Continue to study the movement of stolen devices from the U.S. to other jurisdictions and use that information to encourage other countries to adopt measures to combat the import and use of stolen devices abroad, and to work with relevant standards organizations such as ADIS and industry associations such as GSMA, which operates an IMEI security monitoring and reporting service, to assess mobile device IMEI security levels and the availability of hacking tools to better understand the security of the IMEI. And with that, I did not take as long as I had intended, but I'm happy to answer.
Are there? Oh, there are.
So it sounds like coordinating law enforcement is one of your biggest issues. Do you have a champion at the Justice Department or somewhere high in the federal government that's helping you?
So we had participation on the working group with the Justice Department. And we worked to try to engage the NYPD again. They had been a strong participant in the past, and we talked to them throughout. I think one of the challenges is they don't necessarily have all of the data that we want, and it would require additional effort to pull that data because it's not something that they routinely collect.
But there's not a division of the Justice Department that focuses on a problem like this?
Not that I am aware of a specific.
It's focused in a more generic sense on the type of theft and not the specific item is one of the problems we face.
Okay.
So they will focus on the theft as defined by law, but not that it's a cell phone. And that's one of the problems, is a cell phone becomes some form of theft, legal theft, somewhere up in the value chain. And changing that is fundamentally difficult.
But we have had a champion within the Justice Department throughout, who's been very actively working behind the scenes.
And what division are they in? Just
Institute of Justice.
But to scale the problem, there are 18,000 independent
Jurisdictions
in the United States. And the only thing they respond to actually is grant money. So most of the reporting that the that the DOJ gets is because there are grants tallied to it. So it have to be something very seminal to make this a worthwhile process. And maybe there are more efficient ways. But we have tried about a half a dozen different ways, because I don't want to make Melanie the fall girl for this, but we have tried a number of initiatives. We've worked with DOJ, but it's sort of intrinsic to how law enforcement is organized in the United States.
In fact, the best circumstance was a few years ago, the local Washington, D.C. chief was very hot on this issue. So she intervened with the local chiefs, or the chiefs, major city chiefs, to get them engaged. And we had fairly good response at that time, but she's now moved on, so that's been the problem. Russ?
And so some of the numbers were fairly promising in terms of the drop in thefts. Do you have a way to tie those specifically to certain, is it because of the work you're doing, or is it because of some of the work that device makers are doing, or carriers?
So our sense is it's a combination of both, right? I mean, the timing seems to align with when we saw the anti-theft tools be released, and then the introduction of the stolen phone checker, which, you know, is keeping stolen devices off the market in some ways. So, you know, we aren't, of course, able to determine for a guarantee that that's what led to it, but the timing seems to suggest that the introduction of all of those available tools has dramatically decreased the thefts.
Russ, we also suspect the timing was right in the sense that these capabilities were brought out and publicized when consumers increasingly are putting more important financial information, other account information, as the phone becomes more than a phone. Our suspicion is, and it's only intuition, is that protecting the information rises in value to the consumer.
Jesse?
Melanie, I think my question, I'm sorry about that. But my question is more in the area that Russ was asking about. If you look at some of the work that's being done in terms of AI and other types of applications in 5G, have the group thought about what types of use cases that might make sense to help track and try to get the 20% down by using newer network capability that's being thought of for new networks? Or do you guys have ideas of things you'd like to see the network do that might help you either identify, locate, or whatever the 20% that you've not been able to get down further?
So that's not something that the group focused on this year. If the group comes back next year, perhaps that's an area that we can look into a little more.
Well done on the presentation. My question was around Jesse leveraging AI and machine learning, so I'll withhold that one. But I had a much basic question around eSIM, and was wondering whether that helps alleviate theft, phone theft, or it helps the Scrooge guys out there.
So that's an interesting question, and I admittedly, it's not something that I dug into, but, you know, I'm happy to dig into that a little bit.
I'll add on top of that, the biggest question we had out of the past year is why in the U.S. we're being told that IMEI is basically inviolable, and then you go to the foreign countries and they say, gee, you go down the street and they can clone it. Nobody offered, we're talking to the wrong people, nobody offered a clear explanation of that, but trying to understand, I think we came away with a firm understanding that the FCC might want to understand the whys and wherefores of the security associated with IMEI and perhaps eSIMs, and then look at how we can cast that better internationally. But we have no answer to that other than everything's great in the U.S. and everything is corruptible outside the U.S.
I think it's time for Brian to talk about the great sacrifice that he made on behalf of this working group, personally sacrificing his phone for this purpose. So Brian, it's up to you to share with us.
No phone.
Brian, are you there?
His phone's
He lost his phone.
This really spoils things. Of all people, Brian, who chaired this group for many years, had his iPhone stolen.
Stolen or lost?
Stolen.
Stolen.
And with all of what we have done, he checked the database, the whole business, and didn't have it. He was going to, were he here, he was going to have a placard with a blank space of his memorabilia, his lost, or stolen, I should say, iPhone. So it spoiled everything. Brian must be off already. But in any event, I thought it tremendously ironic that the leader of the group, prior to Melanie, that his phone would have been stolen with all that he knows about and that using the checker and everything else. It was gone and gone forever. So we have not yet solved the problem, is the moral of that whole long story. It is still a considerable challenge. Mark?
Yes, since the story of Brian brings in another question here, is that since you see the reduction, you saw almost of half that showed in the phones. This works, what you're working on now stops phones, which are now worth over $1,000, from being reused. But the components in the phone are worth more than the phone by itself for resale. So what are we doing to address phones being stolen for components? Now, in the past, I brought this up that automobiles used to be stolen all the time. There were chop shops everywhere. And then what they did is the government made a requirement that every single part in a car have a serial number. And then body shops couldn't buy them because it had to have a serial number on it. If it didn't have it, they got caught. And they knew they were buying stolen parts. They couldn't say it wasn't where it got stolen from, but they were in trouble for having stolen parts. So if we could do the same thing with the phone industry, where the parts would have to be serialized. I mean, the automobile manufacturers really didn't want to put serial numbers on all their components. It was an expensive thing. But it almost did stop the auto theft in the U.S. as far as for chopping things up for parts. So maybe, I don't know if you've addressed that or looked at that for phone use.
Let me try, because I think this gets into a cost-reward sort of equation. We actually have no data, and we tried, again, this gets back to the law enforcement problem. We have no understanding of the scope of the parts industry associated with this. So until we had some understanding, I think it would be unfair to try to impose a cost on the industry when you don't even know the size of the problem. And it gets back to the fundamentals. We can track what we can track at the present time, and that's the theft of phones. We have asked questions, but again, our reporting process doesn't lend itself to that type of analysis. I wish it did. We certainly tried over the 3 or 4 years that this group has been in existence. We made a number of attempts. We worked individually with law enforcement people. We went through the Justice Department. The system we have in the United States just doesn't lend itself to that type of analysis. We're not a federated system. And you're starting out with 18,000 agencies, talking 18,000 different languages, and then talking into a polyglot language that doesn't encompass the fineries that you want in this. It's a really complex problem, and it also made, Dennis noted the support from Washington, D.C. These people move around all the time, so what we found is basing policy on personal relationships is a very frail foundation, because within 2 or 3 years, the person that you're counting on is in a different job. So
that's a problem we haven't really tried to address, frankly.
I think we'll conclude here with the remarkable progress that has been made, both in digging in and understanding all of the challenges, and in seeing actual progress being made, which is the ultimate bottom line. I will echo a little bit what Walter has said. When we started this whole activity, we put really beautiful pictures with threads, including the chop shop for phones, with the intent that we would understand where all these devices went and what the flow looked like. And I would say that that still turned out to be a bridge too far. We still do not understand, we understand generically the structure, but we don't understand, as Walter was saying, the real flows. 30% go to chop shops and 40% go to overseas locations. We know anecdotally that these things do all exist, but we still don't know how it really all works. Some of my best insight was from a homeless person in Chicago who explained at least the local level of this, which was quite remarkable that he would understand, whereas the police department didn't have any idea. But he could, were I to have a phone in my hand, as he started the soliloquy, but that there is an understanding at the street level that is not generally available to us at large. So with that, let's call the TAC meeting largely to a...
There is a white paper that this working group generated.
Yes, there is. Thank you very much, Michael. And is it a white paper or a report? How would you?
Report.
It's a report as I saw it,
Yes.
which doesn't require our approval. It's not a white paper, but I'm glad you brought this up because it's quite a comprehensive report that's been generated that parallels the presentation. Hopefully you've all had a chance to take a look at it, but it dives in even greater depth into these areas and took a great deal of work and editorial leadership by Melanie to put that together. So it's quite well done. So again, kudos, Melanie, for that. As we come to a close for this part, remember there's more. But I do want to extend, as I so often do, kudos, but they're extremely well-deserved this time around because, in fact, we're talking about 6 months since this is December plus 3 or 4 months of additional work that's gone into this. So greatly appreciate the work done by the chairs, the co-chairs in the room, and those that are missing as well, and the subgroup chairs as we've divided into subgroups, but certainly to the whole TAC team in pulling together the materials that we've all been enjoying, this feast of information today. Great work. Also always need to recognize the subject matter experts who have contributed so much to the TAC. Beyond the TAC team, we've had the good fortune of having people who affiliate themselves with our working groups, either on a somewhat full-time basis, but often on a one presentation basis to come and bring the knowledge that they have on a specific subject to us so that there is much greater understanding by the experts. It's been one of the great hallmarks of this organization, the ability to bring in world experts to talk about the subjects that are of interest to the TAC. And we've often joked about the fact that we should sell these things, and it was highlighted earlier, putting them up on the web as Dale asked the question, that we should, there are forums where this kind of information being conveyed derive a lot of money for the contributions, but here it's done in a patriotic way, and Nomi really brought that point out earlier, that this, for us as technologists, this is an avenue for demonstrating patriotism and contributing to the greater good of the nation, and that's a wonderful thing on the part of all of you. I would be remiss if I did not highlight the liaisons as well, who have contributed so much to the working groups and steering and helping and occasionally coaching and refereeing. But that's been a tremendous contribution. I'd like to then recognize our past DFO, Designated Federal Officer, one more time, because really have appreciated all that you've done for many years, Walton. And now I'll personalize this. Walt and I have established a very close bond through all this process, and it's really been a tremendous period, and very enjoyable period as we've worked together, labored together to pull together some of the details around the TAC. But he's a great guy to work with, and certainly we've all experienced his leadership and occasional refereeing in steering the course for us. So, Walt, really, really appreciate it. And I think one more round of applause for Walt.
Can I just add on that? If you know?
Well, I was gonna let you.
No,
go ahead, Ray.
about this guy.
This guy.
You know, we had a little celebration when Walter left among the staff here.
Put that a little bit diplomatically.
But I think all of you know just how remarkable a job he has done in really embracing the TAC. He didn't just check the boxes on all the administrative stuff. Every time I would go down to his office to give him another assignment, he'd be on the phone. I thought it was robocalls. But he actually, you know, he wasn't only making sure everything stayed on task, but he was participating in all the groups, and I knew that, and he was helping to contribute to it, and I knew that he felt it really rewarding. And you all know just how badly we miss him here at the commission, but well-deserved, you know, to move on in life, to be close to his family in Texas and so forth. And I, on behalf of the people in OET and all the other folks in the commission you harassed to participate in the TAC, we want to thank you for all you did, Walter. Thanks. Sure.
Again. I'd like to say a couple of things myself. First, since this is the only opportunity I have left for me, I'd like to thank Jeff Reardon and his AV people. I've done this for 8 years now, and they are literally behind the scenes. and I would like to give a shout out to Jeff. We've come to him with a lot of last minute issues or arrangements, and they've always been very gracious in terms of doing this. On another note, I've told some people, not all, you know, I have moved down to Austin, Texas. There were 3 reasons. One, my wife and I saw my retirement as an opportunity to refocus some of our life on our children, and it's a great opportunity for us. Austin is a great city in its own right, which was another reason we moved down there. And I checked, and Potbelly has franchises down there, and anytime I need a TAC lunch, it is available to me, okay? The other thing I'll note, and I've thought a lot about the TAC, and I'll start with something that meant a lot to me when it happened. It made an impression on me. Many years ago, in the 1990s, I read an article in Fortune or Forbes by Andy Grove, and I think I've told some of you this story. But he was reported as riding his bike in the hills of California, musing how he was blindsided by the internet, how Intel was blindsided by the internet. And I found that a very impressive statement, because I'd been working for NYNEX at the point in time, 6 years on internet issues. The internet had celebrated its 20th anniversary, and he was a very bright man, a very man plugged into the technology, who didn't see certain seminal changes occurring. Another thought that occurred to me, because it's very close, I was the program manager for the introduction of optical systems in the Bell system. The first system we put out was in New York City in 1980, and within 2 years, the entire industry had changed. And I can tell you that not only was the public surprised, but departments in Bell Laboratories were caught by surprise in terms of the impact this technology was going to have. Yet there's a seminal paper by Charles Cow in the mid-'60s where he predicted all of this. My point is, changes that are fundamental to technology seem to occur overnight, but the foundation for these changes sometimes take decades to occur. And if I had to argue what was the purpose of the TAC, the purpose of the TAC is to prepare the FCC for change. And it's been a rare opportunity to work with you guys. We've done A number of things. Matthew ticked off a couple of the accomplishments, but I'd also note some of the early work was facilitated deployment of broadband systems, spectrum sharing, cell phone safety that is having a practical impact today. Adam Drobot, in a very provocative way, talked about the demise of the PSTN. And those of you who were here at the time remember the reaction. Everybody at the table knew he was talking about something which was going to happen, was happening, in fact. And yet the public reaction to that was astounding.
Yes.
Now, a kinder Adam might have simply said, look how relaxed the PSTN is. But he chose not to do that. He wanted to make a statement. I wish people understood the rare opportunity the TAC gives the FCC. There's 45 people approximately at this table. As we've noted in the past, 160 people on top of that sometimes devote an hour a week in meeting and more time on their own to making recommendations to the TAC. Since the TAC was chartered, and I was the beginning of the rechartering of the TAC, and in fairness to every chairman since then, they've paid a lot of attention to the TAC recommendations. Some of the recommendations have been easy to implement, and they've been done within the year that the recommendation was made. Others are still being done today because, as I said, technical change takes a long time to accomplish, even though once you reach the tipping point, it looks like it happens overnight. So I'd just like to thank you all. It's been a real pleasure. We're looking at the finest the technology industry has to offer. This has been a voluntary, another thing people should understand, this is a voluntary effort on the part of the companies, and it's the best interest where we have government and industry working in partnership for the common good. I wish...
And academia.
And academia, excuse me, I didn't mean to leave academia or anybody out on this, but the normal activity we have at the commission is what we call the 1-hour meet and greet, where companies come in and pitch something for something they want. Working with you week after week after week builds trust and integrity, gives us an understanding of industry issues, and you help influence things we should be doing. Our goal is to make America successful, to make technology successful, to keep us a leader. If we were an insular organization, we'd be making very stupid decisions. Okay, you're helping us prepare for the future, and I really have appreciated all the time I've spent with you, so I'd like to thank you. On one other note, I'd like to thank Julie Knapp. He's been a great boss. He's the type of guy that lets you do as much as you want to do, as long as you honor the integrity of the working relationship. It's been a pleasure working with him. I truly miss the people of OET. Dennis has been a great guy to work with. And I'm sorry for Michael, who has come to learn final means more to come. And final means no more than 3 more revisions expected.
I learned it from Ross.
So thank you all. I do appreciate it.
With the comments that Walter's made, we're kind of moving slightly out of the sequence that we had, but that's wonderful, and actually I think this is a better sequence. So it's terrific. As our designated federal officer now, and as you've had the introduction from Walter, any comments that you have to close out the TAC meeting itself, reminders and the rest, dates and so on?
You need a microphone.
So about 4 or 5 years ago, I took over another position called IRAC representative. And didn't know exactly what I was getting into, but a lot of people kind of gave me a little look. It took me about a year to realize what I have done. But it has been very rewarding, and I know how much time and effort Walter put into this, and there's a big shoe that I have to fill. And I know there will be a lot of challenges, a lot of late nights, but I'm sure working with the great people will give us a full of energy. And also, Julie has been great supporting a lot of all the other members coming back to the TAC for 2019. Thank you.
Great. Well, we are transitioning visibly into the celebration of 20 years.